So we're now live. Good morning, everyone. My name is Stefan Urevic, and I'm the supervisor of the EU Space Support Office, an organization that, as its name indicates, support users of the various components of the European Union space program, and Copernicus in particular. Obviously, it's my pleasure to welcome you today to our General Assembly. I will be your moderator for the day. A few housekeeping rules before we actually start, although most of you must be by now accustomed to the rules of these online meetings. Your microphones will be, of course, disabled. So will be the chat in WebEx. For your information, we're both on WebEx and on YouTube. On YouTube, there's a slight delay, so for the Q&A, bear with us if sometimes there's a little difference in time. All the questions and answers will be handled through Slido. So I invite you to log on to the Slido once it will be, the QR code and the various login elements will be presented to you. And I hope you will find this day interesting. The team of the Emergency Management Service of Copernicus has worked hard to try and give you an overview of both the achievements and the future developments of the service. So we hope you will enjoy and you will find it interesting. We'll give another 2 minutes to the latecomers to log in. Although I can see there's already 150 participants, which is already quite a nice number. So we're very happy to see that the Emergency Management Service is gathering such a lot of attention. So 1 more minute, and I will start passing the baton to our VIP keynote speakers. Disaster risk reduction and emergency management are all about timeliness and about accuracy. So it's 9:15 sharp, and I declare this General Assembly open. It's my honor and my privilege to pass the floor to Sara Sastamoinen, who is the Deputy Director General of the Joint Research Centre, the Science Hub of the European Commission. And because there is so much science behind the products and the services of the emergency management.
It was now, okay, maybe. Well, this means that I'm indeed welcoming you to the session on the behalf of the Joint Research Centre. I hope that we have the voice over coming well, and I'm really apologize for the problems with the camera side. The Joint Research Centre is the scientific service of the European Commission, as it was mentioned. We are the Directorate General, which has been entrusted to implement the Copernicus Emergency Management Service. We are doing that in close collaboration with the colleagues in DG ECHO, so the European Civil Protection and Humanitarian Aid Operations, and DG DEFIS, the Defence Industry and Space. It's already some time that we have been working on this, so it is more than 12 years now since we started helping to reduce the impacts of disasters on society by turning the data from satellites and models into the products that decision makers, policy makers, emergency responders use. A clear example on this work were, for example, the severe floods that about a month ago hit the Central Europe. The flood forecasts of the European Flood Awareness System, the EFAS, from Copernicus. These helped national authorities and also the Europe's Emergency Response Coordination Centre, the ERCC, to prepare for the event. And in addition, on-demand emergency maps from Copernicus Emergency provided a detailed monitoring of the flooded areas. So that way supported the response to the event. Simultaneously, when we had severe floods in one part, there were several wildfires. Wildfires, for example, in Portugal, and we were spreading rapidly. And these were spreading rapidly on that time due to high temperatures and strong winds. The European Forest Fires Information System was then used, as well as the on-demand mapping component of the Copernicus. And this provided continuous monitoring and mapping of the fires. And again, this work supported the rescue teams and the local authorities to combat that fire. And also then at the European level, the ERCC to mobilize the firefighting planes. So it is a little bit a bittersweet feeling that the emergencies bring. Also on those circumstances, we are proud of the work that the Copernicus has been doing. For us, it's indeed part of our Joint Research Centre's mission. Our mission is to provide independent, evidence-based knowledge and science to support the European policies to positively impact society. But Copernicus is only possible through a very large ecosystem of small and medium enterprises and other partners that provide this 24/7 service. So really a big thank you to all of you who are here today in the conference. Let me finish by sharing that our commitment to science and data and innovation that continues. It continues to enhance resilience and preparedness across Europe and beyond. We are leveraging the advancements of the artificial intelligence. We use new satellite data and cutting-edge technology. With this, we want to ensure the future evolution of Copernicus Emergency also into a global infrastructure. And that way, in the international level, we are also contributing to the United Nations ambition to provide early warnings for all. I want to invite all EU member states to use the tools and the services that are provided by the Copernicus Emergency. By integrating these resources into your disaster management strategies, we can collectively improve our preparedness and response capabilities. I want to stress that preparing a preparedness union with a safer future for all is very high in the priorities of the new Commission that will start. Today, I wish everyone fruitful discussions and plenty of learning opportunities. Let's continue collaborating to improve the disaster risk management for the safer future. Well, if the disasters won't stop, we won't either. So the Europe and the world really can count all of us, all of you. So thank you very much.
Thank you, Madam, for these welcoming words. I will now pass the floor to Michela Matuella, who's the director of the Emergency Response Coordination Center here in Brussels, obviously the hub of all the activities to manage emergencies, disasters around the world. Michela, the floor is yours.
Thank you very much. Good morning to all. It's really a great pleasure to join Sala and Christophe in opening the Copernicus Emergency Management Service General Assembly this morning. It is really a great opportunity to express our appreciation for the excellent cooperation with the JRC and the GTEFIS to manage the Copernicus Emergency Management Service. And let me just mention here, I was in ISPA just a couple of days ago, and we had the opportunity with our respective teams to review the work we are doing together. And I'm really glad I can reiterate in this format also the appreciation for our cooperation. Copernicus is essential for crisis management. Let me also reiterate here and reinforce what Sarah just said and refer to the speech of our President von der Leyen in the European Parliament just a few days ago, where she clearly highlighted the support provided by Copernicus during the floods that have ravaged Central and Eastern Europe in this past period. This was also recalled by Sala just a moment ago. It's another example that we can show together with what we have seen this summer also in the context of the wildfires. Copernicus was activated 22 times on that occasion. So this shows that Copernicus early warning component is essential for us, for the Emergency Response Coordination Center, for our daily work. Because our daily work of monitoring, informing, and coordinating as the crisis coordination hub of the EU and as the operational heart of the Union Civil Protection Mechanism, 24/7 center, this is really an essential component. So the satellite maps also complement the Copernicus early warning component, also with data that for us are essential to build a comprehensive situational awareness and plan a timely response in the immediate aftermath of a disaster when often no primary data is available. So this is really something that we see on our daily work, how important it is, how essential it is. It is a fundamental component of our capacity. And we see that disasters break records year after year. Just open the news every morning and you see what I am talking about. And this comes with significant human and economic losses in a context of increasing insecurity across the globe. And therefore, anticipation, preparedness, early warning, situational awareness are key. This is why the next Commission has decided to focus on different aspects of preparedness with the important task of delivering a union preparedness strategies. Challenges are increasing, whether they come from natural disaster and climate change, or whether they come from security and geopolitical context. It's clear that the Commission has acknowledged the importance of working on preparedness. And in this context, let me also mention the tasking also of preparing the so-called MINISTO report that is also, let's say, complementing on the climate change, let's say, natural disaster angle with the components also that really come from the geopolitical context. And preparedness is a joint effort. From our side, it is important to continue raising awareness of the existing analytical and scientific capacity that we have within ourselves and in cooperation with JRC, and that is also in the context of Copernicus. And it's also an important, of course, component of our work to encourage member states and the participating states of the UCPM to better use the tools, including Copernicus, to complement and enhance, of course, the national capacity, because, of course, our capacities are supporting capacity. When looking at the rapid evolution of risk, whether linked to the impact of climate change, health crisis, defense, it becomes clear that the needs far exceed the resources available. And therefore, we clearly need to shift from reaction to proactive readiness. And it is in this context that Copernicus will play even an increasing essential role in the future. So, therefore, I can conclude by simply saying that we're clearly looking forward to continue working together to further improve the services that we have at disposal with more research, more innovation. And for that, of course, we count very much on the DGJRC, DGDEFIS, but also the many partners in this endeavor that are present today. So I wish you also, from my side, a very fruitful discussion today, counting on the fact that this will be another, let's say, stepping stone in building together this joint capacity. Thank you very much.
Thank you, Madam. I will now pass the floor to Christoph Kautz, who's Director for Satellite Navigation and Earth Observation at DG DEFIS, the Directorate General for Defense Industry and Space. He has both Galileo, EGNOS, and Copernicus under his responsibility. And it's interesting because there are many synergies between these two components, and also there are several emergency response-oriented services that are provided by Galileo, such as the Galileo Search and Rescue or the upcoming emergency warning satellite system. So he's the perfect third and last keynote speaker for this event. Christoph, the floor is yours.
Thank you very much. Ladies and gentlemen, it's a pleasure to be with you today here. And I would like to thank you for the the great interest you have in our annual conference on Copernicus emergency management. So as it was said, DG Defense Industry and Space is responsible for the EU space program, and part of that is the Copernicus Earth observation component. Of course, we do this in cooperation with many partners, and in this specific case, when it comes to the Copernicus emergency management, we do this together with JRC and DG ECHO, and I can only confirm what was just said, that we have an excellent cooperation, and I would like to thank both DGs present here for this excellent cooperation. With regard to Copernicus, we provide vital tools to support disaster management in the EU and beyond. The Copernicus services and the emergency management service in particular supports first responders, helps in assessing damage, in reconstruction. It provides timely and accurate and detailed on-demand mapping and information. And you will hear today from practitioners how they use Copernicus services, and from colleagues from JRC and DG ECHO what they do to make these services as relevant as possible to the users. And as it was mentioned, there's not only Copernicus, there's also Galileo, and there we have a few services which are also valuable and relevant for disaster management. As it was already underlined, the recent wildfires in Greece and Portugal, as well as the floods we have seen across Eastern and Southern Europe, show that unfortunately extreme weather conditions are felt in ever greater parts of Europe, and the projections show that due to climate change, warming seas and oceans, we will be ever more facing such extreme weather conditions. Therefore, we need preparedness, early warning, and constant monitoring. From our side, to enable this, we are constantly improving Copernicus services and data. So only recently, we launched a new Sentinel-2 in orbit, and I can already say that on the 3rd of December, we will launch a new Sentinel-1 into orbit. Furthermore, we are improving the access of users to our data through the Copernicus Space Data Ecosystem and the creation of thematic hubs. But we need to do more. The challenge in these times of climate change and multiple crises is clearly to exploit as much as possible the space assets we have by using also new technologies, AI, digital twins, high-performance computing, to deliver on the 5 disaster resilience goals: anticipate, prepare, alert, respond, and secure. And of course, to make this work in practice, we need partners like the JRC and DG ECHO. The embeddedness of the Copernicus Emergency Management Service within the Union Civil Protection Mechanism is, for example, a key instrument in supporting all phases. And the embeddedness, if I may say, in the scientific knowledge of JRC makes this a state-of-the-art service. I would like also to give you for a moment a more political perspective. We will soon have a new commission. For the first time, we will have a commissioner for defense and space, Commissioner designate Andrius Kubilius. Having a commissioner for space is not only a recognition of how deeply embedded and crucial space is for our everyday life, but it also means giving a more political dimension to our work. And given his responsibility for defense, it also means having a closer look at the climate and security nexus. Clearly, for the next with regard to the next commission, we will have to focus on the development and use of the EU space assets, including, of course, Copernicus. And here we need to live up to our responsibilities. We must deliver and lead from the front when it comes to Copernicus and emergency management in particular. To conclude, I think I can say that the Copernicus Emergency Management Service has been successful for already 12 years. We will do our utmost that this continues and that it will remain successful also in the future. The conference today will be key to profile the current and future collaboration between space and disaster managers. Your feedback as users is very important to us. Only together we can make our services successful. Therefore, I'm glad to see so many participants, be it from the international, national, regional, or city level. I wish you all fruitful discussions and a thriving event. Thank you very much.
Thank you, sir. Thank you very much to you. So it's now time to enter into the meat of the debate and of the discussions. Copernicus is a user-driven program since day one, since it started 26 years ago. There's constant consultation of the users, both the grassroots users and the institutional users, in order to ensure that the service and products that are delivered by the Emergency Management Service of Copernicus actually meet user needs. And in this particular community, user needs usually means lives that are saved, property that is protected. So before we start, I'll reintroduce myself for those maybe 150 people that joined after the actual kickoff. So my name is Stefan Ulevich. I am the supervisor of the European Union Space Program Support Office. We support users from Brussels, but worldwide, answering their questions and in trying to support the various actors in the Copernicus ecosystem in driving user uptake. I'll repeat the housekeeping rules. Your microphones are disabled. You are allowed and invited to put on your cameras if you so desire. The questions and answers will be done by Slido. In fact, there is on Slido now, and I invite you to participate. There is now a little poll. We'd like to know where you come from. What is your interest? Why is your interest in the Copernicus Emergency Management Service? So all the questions will be going in that direction. And as I said in the beginning, we also have this session being retransmitted on YouTube. So we're both on WebEx and on YouTube. So now it's time to start, and with the first panel discussion, I'll pass the baton to the moderator of that session. The session is dedicated to the preparation and response to emergencies in Europe with the help of on-demand maps and disaster warnings. And our gracious moderator will be Gaspar Molnar, who's from DG ECHO, where he's in charge of communication, and he's been responsible for several campaigns, such as the 5 years of Rescue, a campaign called Together One Step Ahead, or another campaign on emergency preparedness. So Gaspar, the floor is yours, and I'll let you introduce the speakers that will be participating in this session.
Thank you very much. Good morning, everyone. So let me introduce indeed the 4 panelists who are going to discuss how data from Copernicus Emergency has been used to anticipate and respond to recent emergencies. First, I introduce Olimpia Imperiali, who is a deputy team leader of the analytical team at the Emergency Response Coordination Center of the European Commission. She has over 15 years of expertise, and she contributed to the development of early warning systems and worked towards the establishment of the mapping, analytical, and scientific capacities of the Emergency Response Coordination Center. Second, we have Antonella Morgillo, is an expert user of Copernicus Emergency Mapping Service for the Italian National Civil Protection Department. She has extensive professional operational experience in impact-based forecasting. Third, we have Peter Salomon. He is working at the Joint Research Center of the European Commission, where he is coordinating the Copernicus Emergency Management Service and is also leading the Copernicus Emergency Management Service flood early warning and monitoring systems, such as the European and global flood awareness systems, as well as the global flood monitoring product. And the 4th panelist is Simona Dalmasso, who is team leader of the on-demand mapping at the Joint Research Center. He is responsible for coordinating the team that delivers critical mapping services to support preparedness, response, and post-disaster recovery efforts. He oversees the team's work to ensure reliable 24/7 service and driving continuous improvements to meet the evolving needs of emergency management. So, after having introduced the 4 panelists, a few words just to remind of us that mid-September Storm Boris brought very heavy rains and strong winds across several countries in Europe. Flooding has affected 11 countries, and 8 member states have activated Copernicus Emergency Management Service Rapid Mapping for flood extent mapping and impact assessment, and no less than 71 products were produced. So on this one, I would like to ask first Simona Dalmasso, when did you receive the request to prepare a map about these floods, and what was this map showing?
Yes, thank you for your question, Gaspar. First of all, I'd like to highlight that the Copernicus on-demand component provides information for the preparedness, the response, and also the post-disaster emergency phases, and is activated on demand in Europe, on demand by the member states, by request of the member states. With respect to the floods in Central Europe, it was the rapid mapping module that was activated to provide information derived from remote sense data to delineate the extent of the flood, but also to assess the damage impact of the event. In 12 days, between the 13th of September to the 25th of September, it was activated 10 times for the flood in Central Europe. And the service covered a total of 43 areas of interest. The area of interest is the specific location that the user requests us to monitor. It's been delivering 49 products and defined more than 60,000 hectares of flooded areas. Specifically for the activation in Italy, since we have Antonella here with us, the service was activated on the 18th of September in the afternoon. Initially over 3 areas of interest in the region of Emilia-Romagna, which is the north center of Italy. The initial request was to delineate the extent of the event, so to assess both the extent but also the evolution of the extent over time. The first products and results were available in the night between the 19th and the 20th of September, so a little bit more than 24 hours. Those products were based on satellite radar imagery acquired in the afternoon of the 19th, more or less. The extent detected was 4,000 hectares of floods. After this initial request, we added together discussing with the end user additional 4 areas of interest on specific towns and cities, and these were required to do the damage assessment, so to quantify the impact of the event on the infrastructures and assets. This analysis was performed using very high resolution satellite optical imagery, but also aerial imagery at the resolution of 10 centimeters. This was acquired thanks to an internal capacity that the on-demand mapping team established in the last years. The service for this specific activation analyzed a total of 6,000 square kilometers and produced 19 thematic maps detailing the situation on the ground. I would like also to highlight that the service, both the rapid mapping and the risk recovery, which is the module that provides products for the preparedness and also post-disaster and reconstruction needs, were activated also last year on the same area. And in particular, the risk recovery module produced an extensive analysis delineating the flood depth over the large part of the Emilia-Romagna region. And that was shown in the picture that was available just a few seconds ago. And it was a very extensive analysis and very complex analysis that we think helped the user to quantify. Yes, this is the picture. So I think I gave you all the answers. The timeline was quite narrow, but within 24 hours, more or less, we were able to respond to the first initial request of the users. Thank you.
Thank you. It was very extensive indeed. So member states received these products. So let me ask Antonella Morghillo, how did the Copernicus on-demand maps help your work, and how was that map useful for the Italian civil protection?
So good morning to everyone. Thank you for Gaspar for the question. The first stage of an emergency is the main challenge in the first stage of an emergency is the lack of information that we have. And so the Copernicus on-demand mapping help us to provide information to first responder and to decision maker. Another crucial point is the timing with which the information comes. arrive. And also in this case, the Copernicus produce the information we need. In fact, in this recent event in Emilia-Romagna of this years, of this September, we triggered the system in a pre-tasking mode, and this enabled us to have first delineation product in a day, in 24 hours. And this was very helpful to support the decision. But speaking about the last year events that as Simone was telling, the two extreme events that we have in Emilia-Romagna resulted in the overflow of all the 23 rivers of the Romagna, so it's a very huge event, and it triggered 1,000 and so Simone has the recent recovery, and all the products that were delivered were very useful for us, not only in the emergency phase when we use the flooded map and all the delineation map, but also just after the emergency, because we use the delineation in the grading map to a first estimate of the damages for asking the solidarity fund. So it was very important, and we used them also for the health measures, prevention measures, because the residence time, the temporal evolution of the flooding that Copernicus provide with the hydrological model and with one of the products that the risk and recovery provide us, was used to estimate the residence time for the prevention for the tiger mosquito in Romagna, so also for the health measure. But I want also to underline that the importance of the Copernicus aerial component, because the data provided by the aerial component allows us to also to locate exactly where the banks, the breaks of where there are the breaks of the embankment, and also the water flow, the direction of the water flow that is not easily detected. It was difficult to detect only with the satellite data. So it was very important, and we use also the aerial component to estimate the number of a part of the number of the 1,000 landslides that was triggered by the event. So at the end, if we don't trigger the system frequently, but typically we trigger the system, the Copernicus system, in national emergency or under the request of the regional civil protection. But the Copernicus is one of the most valuable resources that we have, and in emergency and in the post-emergency phase. So it is very, very important for us.
Thank you very much. It's indeed very interesting. And then maybe let's hear from Olimpia Imperiale one step back. Like, who can initiate the creation of on-demand maps? In which situation is it the ERCC who initiates it, or DG ECHO, or who can trigger the service?
Hi, good morning, everybody. Thank you, Gaspar, for the questions. I'm honored to follow my colleagues Antonella, and interesting what she said, and very nice feedback from national authorities. And here to answer to your questions, we have to divide between inside and outside Europe. Generally speaking, the Copernicus Emergency Management Service is triggered by the authorized users, which are all the member states EU member states and also the Commission service and the EIS. So that is for the EU to use it. So inside the Europe, in particular on-demand mapping is triggered by the member states. Of course, the ERCC has a core role in this activation, and it is the single point, and so it checks together with the GRC the request and validate it normally. That's how it works in general. I would say that outside Europe, it has even a stronger role, because outside Europe, of course, we are triggering directly the Copernicus, because we wanted to support the international relief effort. And so it is very important that that we can provide those important analyses using satellite imageries. And in fact, it is, as also Antonella said, it is a first important assessment to ensure a quick response, because we have data when no other primary data are available, because normally in many situations the responders are not yet there, no? And we are already looking from the image and the analysis behind the image, of course, the impact of that disaster is allowing us to have a comprehensive situational awareness already in the first hour. So it's very, very relevant. So outside Europe, I would say that we are triggering usually, and we can also trigger on behalf of our humanitarian aid partners. So we are using Copernicus very much to support, as I said, the international response effort in case of major disasters. It is also important that to say that indeed the Copernicus is often offered this potential, this link with the early warning component, which is very important to highlight, which I think help very much the member states, in particular, in this case it's inside Europe, and to trigger well in advance in order to save time, because as usual, time is the key factor to a success of an operation. And I stop here.
Thank you. Yeah, you mentioned preparation is key. So maybe this is also a good moment to ask Peter Salomon. While we know that reacting is important, so also possible to foresee perhaps what will happen in the future. So could you please tell us how is Copernicus able to help this better preparation?
Yes, thanks, Gaspar, for the question, and good morning, everybody. So yes, indeed, preparedness is obviously of highest importance also when it comes to disaster risk management. And the emergency management service has, of course, also its early warning system component. This consists of, for floods, for the European and global flood awareness systems. For forest fires, we have the European Forest Fire Information System, and for droughts, the European and global drought observatories. So these provide really vital preparedness information in a wide variety of different forecasting products. But I think one element when it comes to preparedness that is important to highlight here, because in particular when it comes to early warning, this is a clear task and responsibility of member states and the national authorities. And our early warning systems, really the main aim is to support and help the national civil protection and national authorities when it comes to preparedness and helping. So we are not really aiming at public warning, but really the key here is to provide support to the ones that are responsible for public warning, and this is the national authorities. Of course, we also try to provide a European picture. You see that our systems are either European or global scale. So for the colleagues in Brussels in the Emergency Response Coordination Center, having this kind of European and global scale view is very important as well. And then, of course, when I mean complementarity on information, we look, let's take the example of river floods, for example. We provide information on transnational river basins. So you all know that river basins typically don't stop at borders. So we provide a homogeneous information for, let's say, the Danube or any kind of other larger river basin. And we also look a little bit, try to support the authorities with looks that go a little bit further ahead than what national authorities, they are very much focusing on the next 24, 48 hours, because that's where most of the action needs to be done. So we try to give them really this heads up early information with our early warning system a few days even before, so that they can start, that they are aware about a possible event and they can start better preparing. Let me also just quickly say what was mentioned already by Olympia is that we use these systems and the forecast that we produce also to pre-task the on-demand mapping component that Simone nicely described. Typically, or what we often see is our users activate the service when the event is already ongoing, which is sometimes already a bit too late. So we try to provide with the forecast information to start already collecting satellite images, even though an authorized user has not yet activated the on-demand mapping component. And last but not least, just also to highlight, I think it's important to recognize preparedness is important, but preparedness can only work if prevention is properly in place, meaning having risk maps, having risk management plans. And here again, also what has been mentioned by Simone and Antonella before, having these types of information also coming from in particular from the risk and recovery component of the emergency management service plays also an important part when it comes to preparedness. So I stop here. I hand back to you, Gaspar.
Thank you. Yeah, you mentioned national authorities. So maybe Olympia, you can explain how do you see the interest of national civil protection authorities in using Copernicus forecasts in their preparedness?
There is, I have to say, there is an increasing interest from all the EU member states to use Copernicus emergency management service, in particular in the early warning component, and to be better prepared, to be better prepared, and so activate also the rapid mapping in advance. I have to say that this has been clearly asked even by the member states, that we should, as Emergency Response Coordination Center, support them in that effort. Following the floods in 2021 and following the lessons learned that came out of these floods that were affecting Belgium, Germany, and the Netherlands, it has been drawn the lessons that together with the GRC, the ERCC should inform as soon as possible when EFAS, so the flood early warning component of Copernicus, is notifying an upcoming major event. And this is happening regularly since 2021. So we make sure that the national civil protection authorities are notified or are informed, and of course we are offering the support that we can provide through the Union Civil Protection Mechanism in case of need. And this link with the national authorities in preparedness is very much appreciated, and allowed also, of course, to then trigger the rapid mapping in advance, and sometimes using the pre-tasking that Peter was indeed mentioning. So I think that it is to be encouraged to use Copernicus Emergency Management Service, both early warning and rapid mapping, and also the third component is exposure mapping, which also might support a bit of the overall analysis. And I could not repeat what also my director said at the opening, is that we really encourage you member states and to use the service, and eventually to really consider this, to embed it. And I add something, to embed this in their own national systems. It complements and I think enhance the national capacity by having a broader picture. So I think really it is relevant, this forecast and preparedness component.
Thank you very much. This is I think is a good explanation indeed. I would like to use the opportunity that we have someone from the National Authority of Italy with us. So maybe yes, Antonella, could you explain us what is the benefit for the Italian Civil Protection Authority to having access to these forecasts and notifications prepared by the JRC?
Yeah, yes, there are many benefits to having access to this kind of product. Also for, but I would say not only for Italy, that has a 20 years history of early warning. This year we celebrate the 20th anniversary of the early warning system in Italy, but also for the all European civil protection, because the products that delivered from the IFAS, for example, such as the long-term forecast, as well for or the flash flood product, provide the additional and the European perspective of the incoming situation. So it is very important. And as Peter said, also to trigger in time the Copernicus on-demand mapping. But it is important to understand that this issue, that this notification and the products were born to complement the national capacity. So this is the key. The key is to complement. So it is we use the IFAS products, and as Italian Civil Protection, also we participate to the early warning working group to develop and to implement this kind of products in a national perspective. So, however, I want to underline two important things. That one is that it's crucial to ensure the consistency between the European and the national forecast, for example, and also to preserve the coherence between the evaluation, the national and the European evaluation. That is very important, because only working together we can better protect our community and ensure that we remain aware and also prepared. So back to you. I hope that I answered to your question.
Yes, indeed. I think it was very insightful. So we discussed floods a lot, but I would like to ask also Simone again, that what other disasters, wildfires, for example, can you provide on-demand maps for? How can those maps help?
Yes, and indeed, the on-demand mapping component can monitor a wide variety of events. As you mentioned, wildfires is one, but also earthquakes, landslides, or even less common events like we've been monitoring oil spills in the sea, algae blooming movement in the Caribbean area, iceberg movement monitoring in the Northern Sea. And this in particular with the rapid mapping, which helps in the monitoring in the emergency phase. So to understand the extent of the event, but also the impact on the assets and its evolution, because it's able to monitor also the evolution of the event. This is thanks to an excellent coordination and an internal capacity that we have, coordination between with ERCC, as Olympia mentioned, with the service providers who are those that are active 24/7 to receive the request from the users. Each of these actors put a lot of effort actually for the success of the operations. To give you also a concrete example on how busy the rapid mapping can be, in occasion of the floods in Central Europe, so a month ago, we were monitoring 10 parallel activations for floods, but at the same time also a big wildfire in Portugal and in Greece. And just a little later, we started a big activation in Bolivia, which is still ongoing, monitoring an extreme fire with a very high level of magnitude and extent. All of these at the same time, but the service, despite this high workload, didn't suffer any delay. All the products were delivered on time, and it shows also very much the resilience and the setup of all the actors and the stakeholders in this part. I would like also to give you examples on the risk recovery model, because while rapid mapping is very standardized, the risk recovery is much more flexible and can deliver much more complex products. For example, now it's working on drought and water management analysis in Africa, dumping mining around the world, ground deformation analysis in the Azores for the risk prevention in case of volcano eruption. So these products can be very complex, and also they can monitor multi-hazard, so monitor the effect of multiple events at the same time, predict and analyze the risk of that. Okay, and for the second part of the question with respect to the risk recovery, those products are used mainly for the preparation, for the risk analysis, but also for the post-disaster need assessment and reconstruction. Finally, just a final comment for who is interested. We will host next week the Copernicus On Demand user conference. It's on Thursday the 17th. It's an online event. It's possible to subscribe, I guess. I think that in the Slido there are some information about this. We will reopen the registration from tomorrow to Monday. So whoever is interested in joining us to understand and to see which novelties we are bringing in end of this year and next year, it's welcome to attend.
Thank you, Simone.
Thank you very much.
And then just a final question to Peter before we turn to the audience questions. Could you just give us a bit of a direction, where will maps and forecasting develop in the next years, just in a very short outlook?
Yes, thanks, Gaspar. Yes, I'll be short because I see that there are questions coming in already, and we're a bit late on time. So, but I mean, let me just say raise a couple of points here in relation to your question. I mean, we have seen an enormous increase in the availability of satellite data, and this is, of course, greatly part because we have the Copernicus program with its Sentinel satellites. So, and we've just heard this morning there was a new Sentinel-2C already launched. There's new satellite launches planned. So there's really a wealth of this type of, and a strong increase of this type of information coming. Also, when you look at the European, the market segment of space companies in Europe that also start providing this type of information more and more. In comparison to 10 years ago, this was really it's really a big increase. So that's one element. The other element, of course, is, and this is a bit of a buzzword, is AI, artificial intelligence, is of course also impacting the disaster risk management and emergency response. I mean, I'm careful in saying that it's the solution to everything, but it most certainly is a very good additional valuable tool to further improve the way we monitor and predict disasters. And last but not least, We do have also an constant increase in computing power. We've heard and we'll hear probably later about Destination Earth a little bit. The Euro high performance computing system is fully up and running. So these are important elements that we're bringing them together, and you'll hear about it probably when I'll talk this up later about the Copernicus EMS evolution. Bringing them together will provide benefits when it comes, will improve the timeliness of our maps, the quality when it comes to spatial resolution, but also the precision of the forecast. I'm quite confident that in the coming years, this will significantly improve. However, having said that, and that's unfortunately the message I have to end with, is we need it because we know that climate change is driving up the frequency of many weather-driven disasters in Europe and worldwide. So there is a definite need to continue to improve and further develop. I'll hand back to you, Gaspar.
Thank you very much, Peter. Thank you very much to all of you for these very interesting insights. Now let's see what is the most burning question from the audience that we should take. So the first one seems, is it possible to get an access to the data as an academic organization? Could Olympia, maybe you can answer?
The data are open sources, so you can everybody can get access to the data, and the maps can be downloaded from the Copernicus website.
Thank you. Second question, I might have missed the information after the first delivery of images. How often are they updated? Important with fast evolving events. Maybe Simone?
Yes, it's a possibility indeed of the rapid mapping component in particular to have what we call monitoring products. This can be done according to the request of the user on a daily basis or even multi-daily basis, because we have access to all the many, not all, but many satellite, even private companies, thanks to collaboration with the European Space Agency. So we have the capacity to do daily or more than one per day monitoring, definitely.
Thank you. There's a question which I think we already answered. Can a European citizen not affiliated have access to the data of Copernicus EMS? I think we have basically said it's open.
I have, sorry, an additional comment on this, because often I see that people refer to data as a satellite imagery, which is something that we not deliver on our side out of the box. We deliver the products derived from that. But indeed, it's still possible to access the satellite imagery for specific organizations, for example, the authorized users, but also the academy. This is done through the Copernicus data access system, which is managed by the European Space Agency. They require to fill a form and then analyze the specific request. So this data might be available.
Thank you. And maybe time for a last question. The rest we will somehow do with the organizers differently. So in addition to the already mentioned products, does Copernicus provide some sort of emergency landslide mapping products?
Simone, I can maybe answer to that. Yes, because I see there's also many questions on other systems and floods and wildfires. Yes, on-demand mapping basically covers any type of disaster. We have covered lava flow monitoring of volcanoes. We have provided impact information on earthquakes. There was a landslide monitoring. There was Antonella was referring to the aerial component, the IKEA landslide. We monitored using the very high resolution aerial images. So yes, the on-demand mapping is basically able to cover any type of disaster. The early warning and monitoring we have because those are systems that continuously monitor and predict floods, forest fires, and droughts, which are the most impactful, let's say, disasters that we have in Europe today and also worldwide. For these, we have these continuous monitoring systems.
Excellent. Thank you very much. I thank you all the four panelists for participated in this and explained very interesting details to the audience. And I hand back the micro to the Master of Ceremonies, Stefan Orevic. Thank you very much.
Thank you, Gaspar. There's quite a lot of questions because there's 280 of you present in this WebEx conference. We will do our utmost to publish an article or some written answers to these on the Copernicus Emergency Management Service website. I want to also again ask Adelaide to put the slide about the on-demand mapping conference, which is taking place soon. So as said, this conference, we've reopened the registrations. You haven't, I heard, until Monday. There's conflicting information. I heard until tomorrow evening or maybe until Monday. So hurry to register. It's open. You need that password, CEMS 2024. But there you will get information about the achievements of the service, the component over the past 12 months. And you will also be given a demonstration on how to fill in the new service request form, which is basically the triggering, the start of any activation for the on-demand mapping component. So it's now time to pass to the next item on our agenda, which is a keynote by Jesus San Miguel. Jesus is the team leader of wildfire monitoring and early warning services and products and components at the DGJRC. He will present the key findings and the highlights of the 2023 forest fires report and give us a preliminary outlook of how 2023, the report and an outlook on 2024. Jesus, the floor is yours.
Yeah, good morning, everyone. Really happy to be here and happy to see that there is a very large audience today. As Stephen mentioned, I will present I hope you are seeing now the presentation. I will present a short overview of what will come in the 2023 forest fire report. That is a traditional report that we launch every year, lately around October, and it provides a close detailed analysis of the previous season, of the previous year. And then I will present a preliminary look at the 2024 season, where we are now. Just to start with, this the outline. Yes?
Jesus, sorry for interrupting. We don't see your presentation.
Oh, sorry. Okay, yeah, there was a last click that I didn't do. You should see it now, I hope.
Please put it in full screen.
Yes. Okay.
Wonderful. Thank you, Jesus.
Thank you, Stephen. So I said the presentation is on 2023, but as a comparison with 2024. 2023 was a very damaging season in the European Union, and 2024 until recently has been a really mild season because of the different changing conditions or climatic conditions during the season. So this is what the outline reflects, trends of a number of fires, burnt areas in the different years. We will look at the fires of different sizes and how they impact the total burnt area. A little bit on fire danger. Fire danger, as I will show, is very highly correlated with the total burnt area and also with the size of the fires, which is interesting when we look at the conditions, future climate conditions, although we are already experiencing the climate change. So just looking at trends, this graph of the trends in the number of fires and burnt areas in the European Union from 2006 to 2024. Here we use fires bigger than 30 hectares, which allows us to compare data from 2006, when the sentinels were not available, to data that we are mapping today with a larger amount of sensors and satellite data. We can see the blue line is the trend of the number of fires, the histograms are the burnt areas. you can see that the number of fires is clearly increasing. The number of ignitions is increasing for fires bigger than 30 hectares. And the same thing happens with burnt areas, although there is a very high variability in the amount of burnt area from 1 year to the next. But the trend is increasing, despite all the efforts that the European Union, the European Commission, and its member states are putting to extinguish the fires as soon as possible. When we look at fires of different sizes, you have on the left-hand side, in blue and green, fires of around 50 below 500 hectares. And the trend is clearly increasing. So these kind of smaller fires are increasing rapidly in the last years. When we look at very large fires, those in orange and red, that is the bottom line on the left, that is pictured in more detail on the right-hand side, we see that the trend is increasing, but not as rapidly as for fires below 500 hectares. But the trend of fires above 500 hectares, so very large, and above 1,000 hectares is increasing in the European Union. What is interesting to look at is that the proportion of fires that are very large, if we look at the fires that are above 500 hectares, you practically do not see them in the histogram. You have the number of fires on the left and the burnt area on the right. So you see the little circle around the top of the histograms for 2021, 2022, and 2023. You see the proportion is always very small. However, the proportion of the burnt area they cause is very large. So for those 3 years, the fires that were bigger than 500 hectares caused over 60% of the total burnt area. So most of the damage is caused by a very small percentage of very large fires. And that is a little bit the focus that we should have. We should try to avoid that fires become very large, because when they do, it is impossible to extinguish them until the meteorological conditions improve. When we look at the largest fires we have had in the European Union, we can see that many of them were from past seasons. 2003 was the first critical year that we have on the record, mainly in Portugal, but also in Spain. Then we had 2007 in Greece. That was also a very critical season with many people dead because of the fires, mainly in the Peloponnese Peninsula. And then we had 2017 in Portugal. That was really the most critical year in the European Union. In terms of damages, 1.2 million hectares burned and over 130 people killed by the fires. And then we had 2021 again in Greece. But the largest fire that we have ever recorded happened last year in 2023 in the northeast part of Greece. It was a fire that was larger than the 96,000 hectares and killed over 20 people in just a single fire. That brings us to the new reality in which we have fires that, despite all the means we may have from the different member states, the European Commission, they are impossible to extinguish, to control. And something that is interesting is looking at the proportion in 3 different regions of Europe. If we look, the Mediterranean region is the orange one, green is Central Europe, and red is the top Northern Europe. So if we just look at the right-hand side of the graphs in both the burnt area and the number of fires, you see that the proportion of the green part mainly, but also the red part, is increasing, meaning that the number of fires in Central and Northern Europe since 2017 has clearly increased in this region. And the same with the total burnt area. So we see that the fires are happening in areas in which in the past didn't happen. Central and Northern Europe have been kind of safe from forest fires for many years, but that is not the case anymore. So fires are expanding into areas where they didn't happen in the past, and that is obviously clearly related to climate change. When we look at the fire seasons in Europe, and this is 2023, we see that the number of fires and burnt areas are bimodal. So we have a peak of number of fires around spring, late winter and spring, and a second peak of number of fires in the summer, although we can see that the fires occur all throughout the year. When we look at the burnt areas on the right-hand side, the peaks are the same. So we have a peak in spring, but you see the burnt area caused by fires in winter and spring is small because the fire danger conditions under which this fire burns are not drastic and they can be extinguished. When they happen in the summer, the reality is different. So you see on the left-hand side, the number of fires is not as high as in the spring, but the total burnt area is much higher. And on the right-hand side, you can see a peak in October, and that peak in gray is the peak of the fire season in 2017, mainly in Portugal. And this is the trend this year. So this year was fairly mild, as I said. So we had a fairly stable season around or below the average of the last 15 years, except in September. September, we had critical episodes in Portugal and some also in Greece that brought up the total burnt area for the European Union. And now we are currently above the average. And that is the large peak that you can see around mid-September, with nearly 100,000 hectares burnt in just 1 week. The trends in 2014 are these. You can see that if in blue is the average for the period 2006-2023. You can see that we've been, in terms of number of fires, above, but these fires were not extremely large. And in terms of burnt area, we've been within the limits of the average or below, except in September, as I mentioned, because of the fires in Portugal. And that is the cumulative curves of number of fires above the average and burnt areas below the average until September. And we still have a few months, but we don't expect drastic changes in the trends of the number of fires or burnt areas. Something that is interesting to look at when we work with our colleagues in the ECO, one territory that is important for them is the territory that is covered by the UCPM. And you see that in that territory, that is the previous to the last line, we have mapped in the European Forest Fire Information System over 1.5 million hectares, 1.667 thousand hectares. But a large proportion of this area that was burnt in Ukraine. So the war in between Russia, the invasion of Russia of Ukraine, is creating many fires because of the shelling of the bombs, and that is creating wildfires that are difficult to extinguish because of the war conditions, and that create a huge environmental impact. In terms of Natura 2000, this year we are currently at around 34%, so around 140,000 burnt in Natura 2000 in protected areas out of the 410,000 hectares that we have mapped in the system until now. And this is the situation of fire danger. As I said, fire danger is highly correlated with the number of fire, with the total burnt area and the size of the fires. And in 2023, you can see in the cumulative curve on the right or on the weekly trend on the left that we were mainly above the average fire danger. While if we look at 2024, we've been around or below the average most of the fire season. So the conditions, fire danger conditions, when monitored, can clearly reflect the conditions in terms of mainly total burnt area in the European Union. This is the number of fires and the areas in which they were mapped this year. You can see the accumulated cloud in Portugal in blue because that is in the last 30 days, but many fires in the Balkans and also around Ukraine, also in Greece and Turkey. This is the analysis of the impact in Natura 2000. This is in September, we were at around 40%. Now this number has become less compared to the total, and we are around 34% of the total burnt area. In any case, looking at the economic losses directly from fires, just looking at the reconstruction cost of the land cover that was there prior to the fire, the economic losses are around 2.5 billion every year in the European Union. And this is a very conservative estimate. So around 2,500 million euros are lost because of fires. These costs don't include any cost of reconstruction of infrastructure or the cost of firefighting to extinguish these fires. And just finally, the last couple of slides to show this shows on the right hand, on the bottom, you have an axis of the fire danger, and on the left hand side, you have number of fires and the fire size. We look at very large fires, those in yellow and light blue on the right hand side. You see, or the top fires bigger than 20,000 hectares. We see that they only occur when the wildfire danger is extreme or very extreme. So if we know that the conditions in an area are very extreme or very high, we know that if a fire is ignited under those conditions, it probably will escape and will become a very large fire. We are now analyzing the situation in 2024 and looking back and from 2026, 2006 onwards. What you see here are fires of different sizes. We start on the top left, all the fires above 30 hectares. You have on the bottom fire danger, on the y-axis, the total burnt area. You see that the higher the fire danger, the higher the burnt area. When we look at all the fires, if we look at the fires that are bigger than 500 hectares, that the situation is again the same. And something that is interesting, and you can see in the bottom graphs, is that fires that are very large, those bigger than 5,000 or 10,000 hectares, only occur when the fire danger is, I don't know if you can see it, around 600% above the median for the period. So the fire danger conditions are extreme or very extreme, meaning that if we know the conditions of fire danger and we know that they are extreme or very extreme, we can infer the expected total burnt area of a given fire that is ignited. And the idea of this analysis that we are doing with our colleagues in ECHO is to look at the climate change. We know that the number of fires, this was the PESETA-4 study, the number of fires in which the conditions will be very high or very extreme is increasing constantly, and it will become higher as climate change makes more effect on the conditions we have now. So we can only expect that the fires will have a higher intensity and will be larger in the future. And that is a little bit the conclusions. I just leave them here. I don't want to take more time in case there are questions that from the audience. So thank you very much for your attention. I'm ready to answer any questions you may have. Thank you.
Thank you, Jesus. I'm sure there are many questions on Slido, which will appear hopefully on the screen. Depending on their complexity, we'll try to take an adequate number. So the first one is, thank you for the presentation. Do you look at fire weather? Is there any correlation between fire weather and burnt area?
Yes, thank you, Stephen. Thank you very much for the question. That is exactly what I tried to present in the last slide. There is a very, very high correlation between fire weather and burnt area. The higher the fire danger, which becomes is a reality of what the weather conditions are, because the fire danger is computed on basis of relative humidity, max and minimum temperature, precipitation until the given day, reflects exactly the expected total burnt area for a given fire and in total for the European Union.
The second question is, how do the fires in the EU correlate with El Niño or La Niño conditions?
We don't see a very high impact of the El Niño or La Niña conditions in Europe. We have to note that in Europe, our analysis shows that 96% of the ignitions are caused by humans. So the climate conditions have a lot to do with the conditions under which the fires evolve, but not so much about the ignitions. And Europe is a very highly populated area. So normally the ignitions of fires are very fastly detected by the population. And in principle, these conditions are very important, for instance, in Latin America, or maybe important also in the US or Canada, but have a less impact here in Europe.
if you can briefly tell us how you calculate economic losses due to forest fires?
Yeah, the economic losses are computed with a very easy method that looks at the cost of reconstruction. So we compute the reconstruction cost for year 0 and then accumulate these costs for the number of years until whatever land use was present in the pre-fire conditions comes to the same situation in which it was. So for a forest that is 100 years old, we accumulate the reconstruction cost, the replanting for 100 years, and that is the economic loss. So it's a very simple and easy to reproduce the methodology.
Thank you, Jesus. Apologies to the other colleagues that have asked questions, but we're running 10 minutes late on schedule. So we will answer these, as said earlier, in writing on our website, and we will notify the participants to this meeting for which we have emails and registrations. So it's now time to pass to our second panel discussions, which is devoted to how to build water resilience in the EU using early warning data for drought monitoring to guide policy development, because obviously all the data and information produced by the Emergency Management Service is not only for emergency management, but it informs policies in order to try and mitigate climate change or adapt to its impact and consequences. So it's my pleasure to pass the floor to Andrea Toretti, who's the team leader of the European and global drought observatories. These are rather newer components of EMS compared to rapid mapping, for example, but they have, unfortunately, and because of the realities of climate change, they have become very important and very popular, and we're seeing a lot of this in the information from ADO and GDO being published by the media internationally or used by policymakers. So, Andrea, the floor is yours.
Thank you. It's really a pleasure to be here with you all and with my panelists that I'm going to introduce in a few minutes. Drought has been affecting Europe as well as many other regions of the world in the recent years, and we have been all experiencing recurrent, persistent, and extreme drought events, compounded also by other hazards such as heat waves, floods, and so on. The complexity of drought and the difference with respect to other hazards, for instance, floods, is that the drought evolves on several different spatial and temporal scales, and also the impacts are not as well defined, especially in time, as the impacts, for instance, of floods. So this makes more challenging in a way monitoring and forecasting drought and its impacts, and also building resilience with respect to drought. It's really great to talk today about drought resilience, early warning systems, and what should be done and what has been done, because this year is somehow a special one when it comes to drought. As we are going to talk with our panelists, we had key events focused on drought resilience, but also we are going to have in December the UNCCD COP16 with an important focus on drought. The role of, as you know, of the Copernicus European and Global Drought Observatory is clearly to provide data and information focused on ongoing but also that expected drought events as well as heat waves. And this year also we have recently released a global overview that is basically showing how drought has been affecting the large regions of the world, for instance, in South America and the Amazonian, but also in Africa as well as in Europe. This global overview was indeed necessary to indeed raise awareness of what happened, and on the fact that drought represents a global threat and requires an enhanced cooperation to achieve resilience. Now, it's time to move to our panelists, and it's really my pleasure to introduce all of them, starting with Bob Stefanski, that is the chief of the World Meteorological Organization. He's the chief of the Agriculture Meteorological Division of the World Meteorological Organization, also the head of the technical support unit of the well-known Integrated Drought Management Program. We are also going to have with us today Andrea Sudnik, that is the head of the meteorological support for agriculture in the Slovenian Environmental Agency, ARSO. We have Elena Xopalaki, the head of the Climatology, Climate Dynamics and Climate Change group at the Justus Liebig University of Gießen. And we have also with us Pascal Liu, that is a senior scientist at the Climate Environmental Sciences Laboratory in France. So welcome, and I will start now posing the first question to Bob, because he has been leading the organization of the recent Drought +10 Resilience Conference. And I would like to ask Bob, what are the key messages and reflections that you can share with us on the path towards drought resilience and the future of early warning system?
Thank you, thank you, Andrea, and welcome, colleagues. Excuse me, it's still morning here in Geneva. So as Andrea said, we had the Drought Resilience Conference last week with over about 200 people, nearly 300 people. And I think the key thing, again, with the headline of the title of the session, early warning and drought monitoring is very important. But to go the next step into drought resilience, we actually need the other two pillars, as we call them: impact assessments, what are the vulnerabilities, and then developing mitigation plans and preparedness plans. So that's how we can come together on drought resilience. The monitoring and early warning is quite important. Those are linked to actions. So for example, if a monitor or early warning system is indicating maybe a record drought, we can look past, depending where you are in Europe or the world, and see what those impacts were, and then consequently, advise policymakers with their plan to say maybe we should stop, irrigating crops, move livestock to a certain way. For urban and city populations, reduce washing cars and things like that. So that's how we need to integrate that. So that the takeaways from last week, I think, are focused on this panel. We need integrated, proactive, and prospective drought management to cope with the drought issue. And what's very, very key is cross-sectoral and whole of society approaches must be integrated into national drought policies. Now, I know the two Andreas quite well, and we talk a lot about this. We can provide all the technical assistance to a country or a region, but unless they're organized at a national level and talking to one another at a ministry level, it's not going to work. So this is actually one of the biggest stumbling blocks. We definitely need to strengthen data sharing and monitoring systems. And, this is part of the conference, and this is also last week and also the meeting today. Need to mobilize resources and strengthen the political will for drought resilience. It's a challenge, and I think Europe is experiencing this. Just 2 years ago, the images of those houseboats in the Netherlands on the muddy banks. They never really saw that before. And so the Netherlands all of a sudden has to deal with drought. So, that's sort of the key outcomes, and I'll leave it to other panelists. So we just definitely need to have this cross-sectoral issue within an organization, especially at a country level, and seeing how we can go forward to make that country or region more drought resilient. Back to you, Andrea.
Thank you so much, Bob, for sharing with us these highlights from the conference, as you said, that just finished last week, but also to give us these images of unprecedented drought events. For instance, as you mentioned, the Netherlands. I think it's really important. Now I would like to ask Andrea, we know that early warning systems are key to reduce risk associated with drought, but also to enhance preparedness. They rely on several sources of data and robust estimation of uncertainties because, as we say, drought is a very complex hazard. Looking now at Europe, how do you think we should integrate local and regional data and knowledge that are available and make it coherent with the ones that we provide, for instance, through the Copernicus observatories at the continental and also global scale?
Yeah, good morning, everyone, and thank you, Andrea, for your invitation. It's really a pleasure to be with you in such a big group of the people also attending today. Yeah, as you said, drought is complex, but your question is also very complex and difficult to answer. But perhaps to share a little bit of my opinion related to this, I think that first step that we should focus on is developing standardized protocols. Like it was said for other events, we have quite a good established protocols how to share this data and how to empower also the national early warning system. So why this is crucial, of course, it will enable us to in real time to share data and also to ensure that our systems work together very smoothly. So of course, this integration slowly will allow us to really to integrate local observations and all kinds of data model outputs and to contribute to this effectively to this regional drought or global drought monitoring and forecast. I was thinking about, to find some examples from the past and also in recent, let us say, years. And I remember this, for example, a notable example of project focus on this was on interoperability was the EuroGeos project, which somehow tackled this, let us say, very complicated issue. So establishing such a protocol will probably, and for sure, not just probably, require additional technical and human resources and, of course, financial support on country level and also on regional or global level. But perhaps also I'm happy that Bob is with us today. I would like to share with you also information that recently within the framework of WMO expert team on drought, also discussion have also begun how to implement national drought early warning systems and integrate them into the global drought, let us say, classification system. This is so-called implementation plan, which is in the process, in under discussion in the frame of WMO, but this will probably contribute to the WMO global multi-hazard alert system, which is at the moment not the case. And of course, we will contribute also to this early warnings for all initiative, which is going on globally. But then to go back to some our experiences as Drought Management Center in Southeastern Europe, in the last few years, we have also promoted this regionally coherent early warnings approach for different areas in Europe through different European projects, like Dry Danube for Danube Basin, then Clean Forecast for Central and Eastern Europe, Alpine Drought Observatory for Alpine Space. So I think there are quite a lot of work already begun, but we still need to discuss how we will harmonize these things. But then after the final thought I have is related to the national perspective. We are in Slovenia, so we are at the environmental agency, and we launched a national drought monitoring system where we integrate all these aspects of drought from meteorological to hydrological components. But what I would like to stress is that this system provides alerts across Slovenian region, but also at national level, we have to somehow, it demands a high level of communication and consensus among experts. So therefore, I think when we will drill down to the national level or upgrade this on the global level, this communication should be in place. So let me summarize my thoughts. So I think that, of course, the solution, well, technical solutions such as interoperability, they are important, but they are not fully address the challenge. So I think that the solution lies in fostering cooperation and communication among drought teams in the country in national weather and hydrological services, and also international bodies like, for example, on European level, it's Joint Research Center. So with this, I would like to also to mention the importance of the local communities, because this collaborative approach will ensure really coherence and improve the overall effectiveness of the data utilization across different scales. So to finalize, I think that the key success lies in collaboration, standardization, and also community engagement. And this I would to give floor back to you, Andrea.
Thank you very much. You indeed touched some key important aspects, cooperation, for instance, and here I think it is worth also maybe to point to existing or recently launched also initiatives and the key role, for instance, of the Integrated Drought Management Program, the recently launched International Drought Resilience Alliance, but also at the EU level, the now working group on water scarcity and drought, where indeed we will try to, as you said, to enhance the sharing of best practices, trying to achieve standardizations and also these interoperability that are key elements. But you also mentioned, I think, what is important, the local communities and the knowledge and how to integrate. This was also discussed in the Drought Plus 10 and represent indeed one of the challenge. Now, if we think at the development of early warning systems, of course, we cannot leave out the role of artificial intelligence, especially by looking at the coming years. And when it comes to artificial intelligence, we know that it might become one of the key assets for early warning systems, but also to achieve drought resilience. And I would like to ask Elena, what are the advancements that you have been doing within the Horizon 2020 project CLINT, and how this advancement on AI can be used to build the next generation of early warning systems?
Yes, thank you very much, Andrea, and hello to everybody and dear colleagues. I'm so much very tempted to respond to Andrea's comments that were amazing and to the point, but let me give you some more information on what happened, actually, what is happening in the frame of CLINT. So in the context of early warning systems and drought resilience, the CLINT project has made significant advancements by leveraging artificial intelligence and machine learning techniques. These innovations are aimed at improving detection, analysis, and response to extreme droughts, helping to build more robust early warning systems that can adapt to the complexities of a changing climate. But let me highlight a few key areas of progress within the project itself. First of all, AI has been used to enhance traditional drought indices, which previously actually relied on limited data sets such as precipitation or soil moisture to assess drought conditions. These traditional approaches do not account for socioeconomic impacts, and this is actually the big question and the big impact. The CLINT project has developed AI-enhanced impact-based drought indices that go beyond climate data only. These indices integrate hydrometeorological and satellite data, including also biophysical variables like the fraction of absorbed photosynthetically active radiation, the FAPAR anomaly, which is a proxy for vegetation health, and that to more accurately reflect the actual impacts of drought on agriculture, on hydropower production, and of course the water sector. This allows for a much more comprehensive understanding of drought severity and the consequences. Second, CLINT has focused on dimensionality reduction and feature extraction techniques to pinpoint the most critical features of drought, such as intensity, duration, and frequency that contribute to severe impacts. This is very important for early warning systems because it helps prioritize which events to monitor more closely. For example, AI-driven models can identify drought patterns that are most likely to lead to agricultural losses or energy production shortages or water scarcity, and that will allow policymakers to take proactive measures. The project has also pioneered a novel framework combining synthetic drought event generation and factor mapping methods, which helps identify the drivers of these events. This framework is critical for understanding compound events, such as dry winters followed by hot summers, that may not be extreme individually, but together they cause significant impacts on the water, energy, and food sectors. Additionally, AI has been proven useful in analyzing concurrent extremes, where we're talking about multiple extreme events that occur simultaneously, but in different regions. When we're using machine learning, the project developed tools to detect and understand the interdependencies of these events, improving our ability to predict and manage risks associated with multiple extreme climate events. The application of nonlinear statistical methods such as the inhomogeneous J function has allowed the project to separate the effects of climate change from natural variability, which is actually making the predictions much more reliable. And finally, the advancements within the CLINT project demonstrate how AI can improve early warning systems for droughts by making them more responsive, accurate, and able to account for complex socioeconomic impacts. This next generation of early warning systems will be essential in helping us achieve greater drought resilience, safeguarding vital sectors as water, agriculture, and energy from the growing threat of extreme weather events. This is in the frame of CLINT, and we hope that our findings are getting more and more of use to combat the fight against droughts under the climate change. Thank you, Andrea.
Thank you very much, Elena, for sharing with us indeed what has been done within the CLINT project, and it's really great to see that indeed the CLINT developed tools and approaches that can really contribute to move towards what has been also mentioned by Bob on proactive and prospective drought risk management, including impact monitoring, and also what is important, the need, and this has been done by CLINT, as you mentioned, the need to address emergent new type of events that are emerging, for instance, concurrent events, as we have seen in the last couple of years all around the world, or also compound complex events, drought, heat waves, and so on. So this is indeed really important for advancing also and translating these findings into operational tools that can be integrated into early warning systems, enhancing also the skill and the ability of these systems to predict and provide early information on drought, on extreme drought. And now continuing on AI, but moving to somehow the sister project of CLINT, the EXIDA project, I would like to discuss with Pascal, because we know that artificial intelligence and the tools related to artificial intelligence are getting more and more applied in geosciences. But in a way, we see that the applications on drought remain somehow limited. Based on the experience that you have done within the EXIDA project, and also on your experience, what are the challenges that you see on the use of artificial intelligence methods and tools on drought, and how can we use EXIDA findings to boost the development of early warning systems?
Okay, thank you, Andrea. Thank you for the invitation. I will start to recall some of the objectives of EXIDA. So EXIDA is a brother or sister of CLINT for H2020. So we are also doing a research for the attribution of extreme events using machine learning, and droughts are part of the scope of EXIDA, of course. And one of the major challenges that we have tried to tackle for droughts is the identification of drivers of droughts through artificial intelligence. So we used causal analysis. So that's the technical tool that we used, among others, to identify large-scale drivers. So not all droughts are created equal. So we focus on several case studies, so that which included the European droughts or North American droughts. But if we focus on European droughts, we looked at the large scale and local drivers, so which include global climate change, and we were able to separate each of the drivers for this. So what are the implications for this? So that the implications for this are useful for forecasting and anticipation. So forecast, so that's early warning systems. For that's just for seasonal to subseasonal forecasts. So we can identify the conditions that would lead to droughts, so which have immediate use. And then when we talk about the attribution of extreme events, it's also useful for anticipation, so long-term anticipation, to identify identify the probability of occurrence of such droughts depending on where we are. So that's most of the results appear in World Weather Attribution reports. Okay, whenever there is a drought, so there's an ongoing drought in southern Italy and Sicily. So there's a report from this that states that how climate change influences the probability that it occurs and the intensity of the drought that is occurring now. But we have several case studies. Some of them use artificial intelligence, some others don't necessarily use artificial intelligence, but the artificial intelligence schemes that we've been using are really meant to identify the drivers, which is used for which serve as prototypes of early warning systems. The other aspect where Xida has been very strong on is the simulation of worst case scenarios. So we've worked a lot on worst case scenarios for heat waves and cold spells and drought simulation. So we can expect that the worst that is possible is certainly worse than what has been observed so far. And we want to see to what extent we can go beyond the worst that has been observed so far in a climate change context. So that really helps. That is designed to help for anticipating the worst droughts of the future in a climate change context. So that's where artificial intelligence appears. So I don't want to contradict you, Andrea, but with colleagues of CLINT have counted several hundreds of papers that use artificial intelligence for droughts, so which include monitoring or detection or whatever. But the precise use of artificial intelligence for droughts is indeed for an operational use is indeed very low. So with CLINT or Xida, we try to join forces to design tools to have a more operational use of artificial intelligence for drought. But this includes monitoring and forecasting and anticipating. Forecasting and anticipating are two separate things. But if we want to anticipate or forecast, we need to understand the physical drivers of drought. So that's where our point of view is slightly different, but very complementary to what Andrea and Bob presented earlier. So the physical understanding is really the key behind our approach in XIDA and I guess in CLINT too. And I will give you the floor back.
Thank you, Pascal. Thank you for giving these insights into the XIDA project. And I think it's really great that you mentioned that droughts are not all the same. This is indeed the key statement to also understand and assess drought and improve the early warning systems. Droughts are all in a way different in terms of the onset, the evolution, and so on. You mentioned also, I think, an important aspect attributing drought. This is not just a scientific, exercise, but it can really contribute, as you said, to better prepare, to better anticipate, and also to better understand the link between the climate and the water crisis. And this, as we know, is one of the challenges, as also emphasized by the UN Water last year. And the worst case scenarios here, we all know the importance of exploring all the different range of possibilities, even the ones that at the moment look or seems to be very unlikely. And that's also the way we can indeed anticipate and prepare and get ready for all these type of extremes. Now, I would like to make a question to our speakers, our panelists, on what are, according to you, the priorities and the challenges that we should address in terms of early warning system development for drought to achieve resilience, but also what is the role of emerging infrastructure and tools, for instance, related to digital twins and initiatives such as Destination Earth. I would like to start with Bob.
So what is the, do I answer some of the questions there, Andrea? Sorry, what do you want me to respond to?
No, just what are the priorities according to you in terms of early warnings development, and how can we leverage infrastructures such as the digital twins that are appearing in this, let's say, really in these months?
Yeah, no, actually, I was looking at the comments, and actually that's what I was sort of distracted by, but actually it's quite relevant. And this is something that Andrea has a project on. At least from the monitoring side, one challenge going forward, and I think all of the speakers can speak to this, is the issue of the compounding and cascading hazards. So there was something on heat waves that caught my attention, and at WMO I also have colleagues that deal with heat waves as well. I think this is the new challenge, right? So we tend to even, Andrea talked about this multi-hazard early warning systems, and we tend to look at hazards independently or in silos. I don't think we can do that anymore. So Andrea gave a very good talk last week on the issue of compound. So a drought and heat wave and wildfire can happen at the same time, or they can cascade. You can have a drought, you have a dry period that then will turn into a heat wave or a wildfire, and we see this. I think for societies, that's what they experience, right? They don't experience a hazard in the silo, they experience it all at once. So I think this is the biggest challenge, and maybe the AI tools can help with that as well. So that's what I foresee maybe on the technical side of that. But then also, we still need, the impact data and vulnerability data. I think that's one of the key points as well. As you know, we're mostly scientists, climatologists, meteorologists. To be honest, we have a lot of data on the physical side. It's the social side, the impact side, the vulnerability side. We need to do a better job in helping countries developing better preparedness plans for drought. I'll stop there.
Thank you. Andrea, what are your remarks on this point of challenges, priorities, and the use of infrastructure, of emerging infrastructures and tools?
Yeah, we addressed a few times that how complex the drought is. So I think that we know that it's really shaped by a combination of factors, which was mentioned also by Elena and Pascal. And to really integrate all these, let us say, climate variability, land and water management, and also socioeconomic conditions, like also Bob mentioned, this complexity, to integrate this into the early warning system, of course, you have to use and collect and combine diverse data. into single, let us say, coordinated system. And I think that digital twins, there is a great potential, and I'm looking forward to receive some of the, like Pascal said, implication in operational use. This would be very beneficial for let us say, empowering national early warning system or national meteorological services, because I think that this digital twin, or how we name this nowadays, is really a virtual model of real world system, such as also Earth atmosphere is included inside. And of course, probably we will simulate real-time conditions which constantly appearing in new, let us say, with new faces. So I think that what digital twins can bring us and help us, perhaps, I hope so, to better understand how drought might develop. This is one thing. Then secondly, I think they will probably help us to improve our ability to predict or visualize potential outcome of the drought. And probably it will additionally support the analysis of compounded cascading events, what also Bob mentioned, which are also our reality nowadays. And they are getting, and the drought beside this is getting therefore much more complex issue to monitor and also to forecast. So I hope that it sits a very strong potential inside, and I'm really looking forward to the outcome of this really operationally oriented research project, which were presented by Pascal and Elena. So back to you, Andrea.
Thank you. Now I would like to ask the same to Ellen and then to Pascal, but also add, because by reading the comments in the chat, if you could also maybe reflect on AI, how to indeed, let's say, move away from this AI as a black box concept. So Elena?
Yes, thank you very much. I think it's my idea behind the question. I mean, of how I would like to frame the consideration of the challenges, and what we need to do is bridging the previous responses of everybody, and also what was now addressed by Bob and Andrea, and I'm sure this is welcome as well from Pascal. Advancing early warning systems for drought resilience. I think that one of the most critical challenges is actually the shift towards the impact-based forecasting. Impact forecasting, compound events, cascading effects, which is actually, we go beyond predicting the physical occurrence, but we are going to the anticipation of their socioeconomic and environmental impacts. For this, as already mentioned, we do require the integration of different data sets across hydrological, agricultural, ecological systems, particularly as drought, it's not affecting only hydrology and energy and the water sector, but it is, as we heard already before, actually a driver behind wildfires. Digital twins, these are actually playing a very crucial role to the simulation of near real-time interactions between drought, vegetation stress, fire risks. These are actually, it's our opportunity to have a more holistic view of potential impacts. And there, AI is at the forefront of this transformation. It's a powerful tool for prediction and data mining. It can analyze complex data streams from remote sensing platforms, from IoT devices and climate models to forecast, and that not only the likelihood of drought, but also the cascading effects on different sectors, and of course the wildfire potential. Black box AI. No, this is something that we are avoiding as much as we can. We cannot use AI only without considering the physical interpretation, without considering the dynamics of the system. So this is actually a way to combine, to prepare and science informed early warning systems using AI, but taking into consideration everything that is behind in the climate system. Further, high performance computing additional tools are essential because we do have a vast we have vast data sets, and we do need to have this near real time, the impact-based forecast, in order to be prepared to that everything that is required for this proactive decision making. And when we are incorporating socioeconomic data, leveraging AI-driven insights, keeping constantly the knowledge, the understanding of the climate science, of the climate system, and early warning systems can shift from just hazard detection to prediction of specific impacts, which is actually going to allow for targeted interventions that will enhance drought resilience across multiple sectors. And then something that was already discussed before, international communication and standardization of prediction, response, and the mitigation strategies. These are really crucial. There are different efforts taking place at this very moment, like the Horizon Europe Medusa project, the Mediterranean and Pan-European Early Warning System for Natural Hazards, and initiatives like the ITU Global Initiative on Resilience to Natural Hazards. They do foster collaboration across borders, and that is not only across political borders, but they are across borders of in science. When linking tools like digital twins with these platforms, we can then share best practices, harmonize forecasting methods, and create a globally coordinated approach to real-time impact-based forecasting. I think this is what is enhancing drought resilience and is improving responses to natural hazards on a larger scale. And these are, again, the challenges and then the priorities that we see that are currently requiring more work, more attention. But again, there are already efforts taking place. So we will be very happy to share with you. Back to you, Andrea. Thank you.
Thank you, Elena. Pascal, what do you think about these challenges, the infrastructure and the AI interpreted as black boxes or seen as black boxes?
Yes, I completely agree with what Elena just said. So I wanted to come back to 2 points. So the first one is that in most projects like XIDA or CLINT, we do forensic analysis in the sense that we, or even the world weather attribution, we wait until something happens and we make an analysis on it, but we don't make forecast or early warning systems. So that's the ultimate goal of the project, to have the tools to do this, which will be handed to national services or international services, but it's not the goal. We don't have the power to do this, and we are not empowered to do this. We don't have even the right to do it. We can devise the tools to hand them, but we cannot issue warnings because in France, this is not our role. For instance, I'm in France, and I guess that that would not be our role in the UK or in Germany, or which are the countries which are present in XIDA. So we design tools. So and we test those tools on already existing events, and we make sure that they work and that they give us the right answer. So regarding artificial intelligence as a black box, in a way it's a black box, okay, but it's we are all the sons or daughters of René Descartes, and we all have to wonder, is it true? And why is it true? Okay, and this happens with artificial intelligence. If we have to use it as a black box, I don't this might be a problem or not. We always wonder if it gives the right answer for the right reason, and this is the core of the research. We try to identify drivers of extremes. We use AI or not, but at the end of the day, we have to tell whether the answer that we provide is physically consistent, and where does the physical consistency appear in the AI, which is explainable AI. So we can't afford using AI as a black box and without even checking why it gives the right or wrong answer. So at the end of the day, when we use AI, generally speaking, if you look at the forecast of GraphCast, for instance, or AI-based weather forecast, of course, the scores are great, and more than 80%, 90%, 99%. But what's interesting is when it fails, why does it fail? And the reasons for failure for forecasts are more interesting than the reasons of success, because it tells you, it can tell you something about the physics or the things that are missing in the AI. So that's why the issue of using AI as a black box is, in practice, for research purposes, a non-issue, because we're all trying to understand why it works and why it does not work and where it fails. And this is an important message when we are using AI for either forecast or anticipation to understand events that have occurred before.
I'm sorry, Andrea, I'll have to interrupt you. And this, I think, on this philosophical point, I think it's a good point to start. Our delay vis-a-vis the program is increasing. So I all invite you to take a short coffee break. We'll be back at 10:30 after this really interesting discussion with other interesting discussions then. See you in 10 minutes.
Hello, Stefan, you are muted. Sorry to interrupt.
Sorry. So it's 11:30, time to resume our discussions. I think I can speak on behalf of the entire Copernicus Emergency Management Service team and also on behalf of the team that prepared this event. We're really thrilled to see 250 of you still participating at this time. So we will now move to the next panel. The moderator will be Thomas Kemper, who's leading the Global Human Settlement Layer project at DGGRC. The data sets from this layer inform the exposure mapping component of Copernicus Emergency Management Service with information on the presence of human settlements and built-up population. And it supports also the Sustainable Development Goals. So they will discuss how to track human presence in urbanized areas to reduce vulnerability and support climate change and adaptation in EU cities. Thomas, the floor is yours.
Yeah, thank you, Stefan, for this introduction, and welcome again to all of you. I hope you still have some stamina to go through the different topics of the Copernicus Emergency Management Service. As mentioned by Stefan, our data are used also a bit broader. So what I'm going to do with my panel today is to step out a bit of the direct crisis management emergency response. You have seen already that our data are baseline data that is used a lot by the different components of the Copernicus Emergency Management Service, always to understand how people are affected, how many people are affected, where are the built-up areas, etc. But this information can be very relevant also for other topics. And that's why I've invited for our panel today three distinguished speakers that are coming from a more urban application domain. So let me introduce my panel, and after that panel presentation, since we are still a bit new to this Copernicus Emergency Management domain, I will give a short overview of the data that is available by the Global Human Settlement Layer, and then we will engage with the discussion with the panelists. Let me first introduce now the panel. We have today with us Claudia Barancelli, who is leading the Geospatial Lab in the Center for Entrepreneurship, SMEs, Regions and Cities, and for Economic Analysis, Data and Statistics at the OECD. Then we have with us Luca Arbau, who is working on the implementation of the EU mission on adaptations on the Covenant of Mayors, which is one of Europe's adaptation pillars. And we have Joachim Maas, who is a policy officer at the Policy Development and Economic Analysis Unit of the Director General for Regional and Urban Policy at the European Commission. Welcome to all of you. And let me now quickly start sharing, if I am allowed to do so. I will share my slides. I hope they are coming to presentation mode. Yes, so I will give you a very quick overview of the Global Human Settlement Layer that you see here. It's a global product, so what we are trying to do with this data set is we are monitoring the human presence on the planet in a consistent way. And we are addressing this here as three main topics. On the one hand, the population, built-up areas, and the settlements. So we are trying to identify villages, towns, and cities. And what is very important for us, being part of Copernicus also, to deliver free and open and fair data, so information that is easily retrievable and findable. And in the afternoon session, if you are interested, we will show you how you can access our data. With the integration of GHSL in the Copernicus Emergency Management Service, we are also now really providing operational products that are updated frequently. In very short, without going into details, for more technical interests, have a look at the recent publication that you can see from the QR code at the bottom. We are using satellite imagery, in the past only Landsat, and since the advent of the Copernicus Sentinels, we're using mostly Sentinel-2 to map the buildings and get an estimate of the built-up surface for all areas on the globe. And the second step, we are combining this with census information to come up with highly accurate and highly detailed population maps. And those two ingredients are then used to also delineate settlements, so that we know exactly how big cities are and where in the first place all the cities in the world are. So let's have a quick look at what is there. We are looking here at Ghana, where you see also the growth of the settlements over time. So we are covering a time frame from 1975 until 2030 with some short-term projection. And the same you can also see for the built-up, for the population data, where there's a massive influx of population and growth of population here in the capital area of Ghana. And the third product, main product, is then the classification of cities, that is using the definition of the degree of urbanization that was initially developed for Europe, but thanks to our global data could then be applied also globally, and it is now endorsed by the UN Statistical Commission for international comparison of urbanization. So the satellite data provide also much more information. So we are able to derive information on green spaces and open spaces. That's what you see on this map here for the year 2018. Again, looking at Ghana, so we have largely three classes. We have in reddish tones built up information on residential buildings, so where people are living, and we can understand also the building height there. In the pink colors, we see where the industrial areas are, and then we also able to characterize the open spaces, whether they are open spaces, sealed surfaces, or vegetative spaces. And that can then really help you to collect a lot of information. So in the first place, with the degree of urbanization, we are able to outline the extent of all the cities. And you see here one example where the cities are marked, and we are then combining this information with additional information from other open sources. So I'm showing here the example for Paris, where we collect information about inhabitants, but also, for example, about exposure, using exposure data sets that were provided by the other colleagues from the Copernicus Emergency Management Service. And we are now updating also this data sets. If you are coming to the World Urban Forum, we will launch it there, but then this data set will also, of course, be available online. And what you can do with information like this is then you can really do a comparison of all the cities in the world, how the evolution will be for very different topics. I'm here just bringing the example of floods. And I mentioned that we are now moving into operational production, so that is really an important milestone for us. That now with our providers working hard to deliver the first global data set for the year 2022 that will be released in December. We will start really having every 2 years an update of our data set that would increase the data availability on our site significantly. And with that, I stop my presentation, and I think we are ready for the discussion with our esteemed panelists. So let me start to reach out to Luca from the European Covenant of Mayors. The Covenant of Mayors for Climate and Energy is an initiative supported by the European Commission that brings together thousands of local governments that want to secure a better future for their citizens. How is the Covenant supporting the cities in Europe? And what are actually the main climate-related hazards that cities in Europe are facing. Luca, are you there? I see only Claudia and Joachim. Okay, Luca, I hope is coming back at some point. I saw him earlier in the session. So maybe I move on then now to Joachim. You're working at DG Regio, and regional policy is the EU's main investment policy. It supports job creation, competitiveness, economic growth, improves quality of life and sustainable development, and tries to really do this by making sure that all regions are growing at the same pace. But there's a focus a lot on economy. What is the role of climate adaptation in your policy?
Well, thank you. And I just see that Luca is waiting in the lobby, so you might want to let him in. So as you said, the main aim of regional policy, or we call it also cohesion policy, is to reduce economic, social, and territorial disparities in the EU. So we essentially help the less developed regions to catch up. And for this programming period, which in the Commission runs from, in the EU runs from 21 to 27, we have a budget of 400 billion euro. Of this 400 billion, 1/3 goes to climate action, actually. So, but most of that third goes to mitigation action. So, for instance, building renewable energy. Only 13 up to 20 billion euro is actually devoted to the adaptation to climate change. So that's the minor part of the climate budget. How do we use this? We fund projects that increase the resilience of regions to climate impacts, but notably on, I would say, forest fires, on droughts, and on floods. Besides that, we have also a solidarity fund, and that we can use for post-disaster relief support, but only once when a disaster has happened. Two important challenges, I think, for the future related to this. Now the budget is going mostly to the less developed regions. It's based on GDP per capita. However, climate impacts, they don't care about GDP per capita. They happen across the Union. Mainly coastal regions are impacted. Also the Mediterranean, islands, cities during summer because of heat waves, or what we have seen last month in Austria, Czechia, Poland, heavy or extreme precipitation events, and these can happen across the EU. So we are faced with the question on how we can actually factor in this climate reality in the new EU budget. So this is something on which we are working. I think also a second challenge for our policy is how to move from a more reactive policy to a proactive policy on climate impact and climate change adaptation. Now the EU pays 50 to 60 billion euro damages per year for extreme weather events. That's 5 times the budget that we have for a 7-year period. So we really have to think on how we can make best use of EU budgets to scale up regional resilience. Thank you.
Okay. Thank you, Joachim. And I think, you made it clear that maybe we have to rethink a bit the way we are dealing with mitigation and adaptation. I think there we have to find a good balance. So, Luca, I hope you are back. Let me get back to you. I don't know if you got my question earlier. I introduced the EU Government of Mayors for Climate and Energy is an initiative of the EU. That is bringing together thousands of local governments that want to secure a better future for their citizens. How is the government supporting those cities in Europe, and what are actually the main hazards that you are addressing in your work? So what the cities are wanting from you?
Thanks, Thomas, and sorry, I had some issues with my computer, so I had to reconnect. Thanks for the invitation, first of all, and good morning, everyone. So yeah, as you said, the Covenant of Mayors is an initiative supported by the European Commission, which currently has almost 12,000 signatories around Europe. We basically work on 3 different pillars that basically articulate all our actions, and these 3 pillars are climate adaptation, climate mitigation, and energy poverty. The Covenant aims to provide a framework for local energy and climate action. So basically, we do this through the establishment of a platform that is called My Covenant, where basically cities can report their successes and also like track how they're doing in climate action. Of course, our aim is also to provide visibility and give an opportunity for cities to showcase what they are doing, how they're acting in climate change and in energy poverty, and of course also learning from others. So we also provide peer-to-peer support and make sure that we connect different cities in Europe so they have the opportunity to learn from each other. At the same time, we also, of course, mobilize local and regional governments and representatives from both the political and technical side, let's say, to raise their voices towards the European Commission first, but also national government and other like national, EU, and international stakeholders. Currently, for example, we are promoting the City Detox campaign on the decarbonization of heating and cooling systems. As this one, next year we will focus on more adaptation angle. So, for example, we are probably going to focus on heat waves. And this connects me to your second question. When you asked about the main climate hazards, let's say that on this specific question, I can give you 2 different reflections. The first one is what we are hearing a lot from cities, but also like we have heard from the European Environment Agency, that Europe is the continent that is heating like twice as fast as the rest of the globe. So of course, heat waves are really a concern from European cities. This is also proven by the European Commission survey that was launched to the signatories of the mission on adaptation. And they, let's say the heat waves were the most popular threat when it comes to climate hazards. Followed, of course, by storms and still water scarcity and droughts being there. And this connects me to my second point, that it's more related to water itself. Water is so actions concentrating on waters are the most common that our signatories are taking in the Covenant of Mayors when it comes to climate adaptation action. And this for sure has to be highlighted, and it's important because we are recognizing more and more that water is a sort of cross-cutting field when it comes to climate action. And it puts together, let's say, solutions to both climatic and not climatic risk drivers, as also the European Environment Agency has stated in the first European climate risk assessment. So I think it's important when we address climate adaptation, not only to look at specific threats, but start looking also at sectors. So how, for example, ecosystems, infrastructure, food, health are impacted by climatic and not climatic risk drivers, so that we are not taking only specific action and more let's say, reactive actions to heat waves, for example, but we are thinking in a more transformative way for our cities on how we can achieve like more long-term goals to improve like also different sectors in the city. And I would say like, I would stop here maybe for now.
Okay. Thank you, Luca. Yeah, so that also already clarifies quite a bit the very different angles that you as a covenant of mayors are addressing. Let's move now to the OECD, to Claudia Baranzelli. You are leading there the Geospatial Lab, Claudia, and this lab aims to develop and disseminate policy-relevant analysis based on geospatial information. What actually are you currently working on?
Thank you, Thomas, and good morning, good afternoon, everybody. I'm really happy to be on this panel. So I will try to summarize really in a nutshell what we are doing at the OECD Geospatial Lab. It's quite a nice, let's say, network or community of experts, practitioners, and in general stakeholders who, as you said, Thomas, are interested in the production and in the use of geospatial data and geospatial analysis. So in its mandate, the Geospatial Lab is quite wide. We do work a lot on climate-related issues, and the work that we do is also immediately relevant also for and used for flagship publications such as Regions and Cities at a Glance. I'm happy actually to announce that this year edition will be published and disseminated at the beginning of December. And there we have a chapter that is indeed dedicated to regions and cities tackling climate emergencies. So there we are investigating especially climate impacts and the progress of OECD regions and cities towards achieving climate neutrality by 2050. And there you'll see some of the work that we do in the lab, where we disseminate indicators on greenhouse gas emissions, sectoral drivers of emissions. I'm actually happy that the previous speakers also mentioned the necessity to look at different sectors at the same time, climate impacts, and also climate projections. The way we work in the lab is actually quite nice because, of course, we do have our official counterparts in our member states, OECD member states, but we can also work and collaborate with other stakeholders coming from the academia or the research world, regional or local authorities, and in also the private sector. So in general, any stakeholder would be interested in the use and production of geospatial data. In this sense, we try to go a little bit beyond what is currently done for the production of statistics, also related to climate change. And we push for the for investigating alternative data sources. And I can mention a couple of topics that we are currently focusing on. One is urban fabric, which is very much related to the work that the GHSL team at JRC is producing, where we are interested in actually exploring new ways or alternative ways that could be complementary to GHSL to describe and monitor urban fabric. We do have also a stream of work that is dedicated to foundational data layers, such as buildings. Here we are collecting the interest of many different partners from international institutions like IMF, so the International Monetary Fund, the World Bank, UN Habitat, and the UN, but also national statistical offices and other private or not for profit companies such as HOT, Humanitarian OpenStreetMap, and Overture Maps. And there, the idea is really to work together, as many probably have already thought of, but it's still, I think it's still missing, or at least this is the message that I got from our stakeholders, a common more consolidated way to work together on producing these foundational data layers that can be then used for many different applications. And I think one important point that is being discussed is also how to integrate obviously different sources of data coming from open products, but also data coming from registries and non immediately readily available sources that maybe single countries are producing. So we do work a lot on innovative data sources, and maybe another example that I want to mention is related to mobile phone data. Again, many possible different applications, and it's a really interesting new source or relatively recent source of data, but that still presents many challenges, not just technical challenges, in order to be fully integrated in, for instance, the data pipelines that national statistical offices have already in place. So this is yet again another avenue of research that we are following, and I think what's important to mention is that the different areas that we are working on, they are somehow flagged by our own stakeholders. So of course, as OECD, we have, for instance, I mentioned before, our flagship publications for which we need to produce content in line with also the comments of our member states. But at the same time, in the lab, we have this opportunity to work also on a little bit more experimental activities, while maintaining an eye on the next step, which is how to make a new technology or a new data source or a new methodology integrated in a wider production of indicators. Because again, at the OECD, we are quite concerned about and interested in producing data and analysis that can facilitate international comparison. So eventually, that's also one of our goal, also with the work of the Geospatial Lab. Thank you.
Thank you, Claudia. Yeah, so you're working a bit similar than we are doing here at the JRC. We also try to support with our science the policy making in Brussels and beyond. So I'm keen to follow up also on some of the topics that you mentioned that could be of interest for us. So I invited you, of course, also to understand a bit on what is your interest in the data that are produced by the Copernicus Emergency Management Service, and of course, more specifically by the Global Human Settlement Layer. And I would like to address first Joachim, because Regio was actually and still is one of the main sponsors of the work of GHSL over time, even before it was becoming part of the Copernicus Emergency Management Service. So what made you invest in that, and what are, according to you, the main achievements here so far?
Okay. I'll keep this short also in terms of time, because we are running late. But for us, for cohesion policy, it's very simple. We need to know where people are on the map. We have a place-based or a territorial policy. We invest in things like infrastructure, transport, energy, but also wastewater treatment, SME. So it's a whole variety of investments for which we need to know where people are so that we can reach maximum impact of our policy. And we need to know how this is going to change either in the past or in the future. So that's crucially important for us. So clearly having sort of accurate gridded built up and population maps serves that goal of the policy. Moreover, if we evaluate our policy, we usually do that by looking at per capita or per person indicators. So again, a reason to have good information on credit population and built up areas. I think the main strengths of GHSL is, for me, first, it helped us develop this international or global standard on degree of urbanization, which allows us again to compare apples with apples. So we do comparisons of our policy impacts in cities, in rural areas, and this helps us actually, making these statistical comparisons. But I think most importantly, I think the strength now, and this is also why I very much welcome the integration in Copernicus and in the emergency service, is that we can start combining these data with other Earth observation data, which are essential for monitoring the impact of our policies. And we have been in the past underutilizing Copernicus and Earth observation as a data source for measuring the impacts that we have in areas like climate and land use and environmental policy, even if they represent a very substantial part of our budget. So I hope in the future that this integration of GHSL in this service of Copernicus can help us and can advance our monitoring systems for a territorial policy like cohesion. Thank you.
Thank you, Joachim. Claudia, you were also using the GHSL data, for example, in the Cities of the World report. And you mentioned also some in your first intervention that you make use of our data. But what is it that makes the data appealing to you?
Well, this has been already mentioned several times, so I'm going to be a little bit repetitive, but I think it's really important to stress two strong pros, two strong points of the GHSL data and layers. One is the coverage and the consistency of the methodology that is applied all across different countries and different territories. This again is fundamental if we want to have internationally comparable indicators and analyses. This, of course, doesn't mean that we cannot have more ad hoc zooms or analysis for specific places for which we may have country-specific data sources or data coming from other sources that are available only in specific areas. But nonetheless, the GHSL constitutes a very nice common basis from which to start, basically. And the second point, again, I'm going to repeat the other speakers, but is exactly the possibility to use this data source for monitoring. So we need long or relatively long time series, especially if we want to investigate certain dynamics or certain phenomena, and being sure that along this time series we are not just across places, but also across, a long time. We're comparing apple with apple. That's really, really important. In perspective, I think I'm actually very happy with the direction that your work is taking, because you are also integrating now new dimensions in your data, for instance, the building height. And again, in perspective, that constitutes a very nice starting point to work on other data products that maybe in the future, why not, plugged in GHSL, even if coming from different projects or different work. So this is a little bit more of a hope for collaboration than in the future.
Okay.
Thanks.
Thank you, Claudia. So you are more working like also Joachim at the regional level. We are not working so closely with cities, and that's why I'm very happy that we are having today Luca with us. So Luca, are the cities in Europe ready to work with geospatial data that we are producing with the GHSL, and at the level of the Covenant of Mayors, are you using the data?
So maybe I will start from the end. From the Covenant of Mayors side, I think our role in using this kind of data is the facilitation role, no? So putting like on the same table the cities, so the end users, with the service providers. So and also making sure that we can facilitate an environment where the cities are understanding what these data are useful for, that capacities are built also in the cities to make sure that this data can be used. And at the same time also like making sure that the needs and the requirements in cities are also communicated to the service providers, of course. We are currently working with the European Space Agency, also already since last year, and their stakeholder engagement facility particularly. At the same time also with DG Defense and the USPA, the Agency for Space. But I think what we need to highlight is that still we are, I mean, talking also with our signatories and with our cities, we're understanding that that the cities are not all ready to use this data at this moment. So answering your first question, are all cities ready to use this data? No, not all of them. We had a practitioner workshop also, mobilizing different practitioners from different cities around Europe, like also using a survey to make sure that we understood what was the understanding of this data and of their usability. And let's say there is a mixed understanding of what's available on how this can be useful for them. And overall, like there are so many open questions in cities about like, are these data free? Where can I find them? How can I acquire technical capacity to understand them and also use them? What is the language we can access this data? Are they all going to be only in English, or are we planning to have also translation in other languages? So I think in general we will have a sort of divide between the big cities and the middle and small size cities, where the second ones, they are going to struggle more to make sure that these data that can really be integrated and used in their daily work. And I want to highlight in the practitioner workshop, it was clear that there is a lot of interest in this data. I think no one is saying that that these are not useful, but I think like it's important that we also get the cities prepared for innovation, for this big change that we are seeing also happening at the geospatial from a geospatial perspective. So I want to say, I think it's a matter of justice, and particularly also on integrating like all different cities in this process. And we are happy to be involved in the process and making sure that we are building capacities in cities. But at the same time, I think we need like to discuss in the next months and years on how to make this happen more concretely, how to also like mobilize other important stakeholders, not only at the local level, but at different levels, to make sure that this is happening in a fair way and in a like just transition way, just resilient way.
Okay, thank you, Luca. So you mentioned some of the points on how to get there. Are we already running later, Stefan?
Yeah, I would suggest we move on to the questions. We have.
Okay,
we're still within the 10. Well, we're right on time, but it's time to go to questions.
Okay, very good. Let's then go to the questions. We've received, the first one goes to you, Joachim. What is the current thinking on how to use Earth observation climate data for budgetary decisions of Reggio where to invest?
Yeah, I was actually typing it already in the reply, but I can just say it out loud now. The current thinking is that the next EU budget should be a bit more performance-based. So what that means is that investments under the EU budget should be coupled to reforms in countries so that these investments have a maximum impact. This requires actually that we also think of setting up a more performant, I would say even a near real-time monitoring system to track progress of EU countries to achieve specific policy goals. There is a process called European semester now, where on an annual basis, the Commission evaluates how countries are using the EU budget and implementing EU policy. The problem we face is that often our data and our indicators are dated. They are 2-3 years old for environment, sometimes even older. Moving to a more performant monitoring system of EU policies, I think there Earth observation, climate data, Copernicus services can play a very big role, just because they have the capacity to be to cover Europe, to have high spatial resolution, and to monitor the planet in near real time. So I think here, I mean, these are the options, and the fact that we have these services, we should use them and implement them better in the next budget period. Thank you.
Thank you. The next question, Claudia, I think this is partly going to you because you were mentioning mobile phone data. I have also one example maybe to share, but let's see what you have to say to that, Claudia.
Yes, thank you. Thank you, Thomas, and thank you for the question. I actually made it on time to type it in the chat. So just to, well, first of all, in terms of which data I'm referring to more specifically, it can be of basically two types, either anonymized data from mobile phone operators, so therefore linked to, for instance, calls or messaging, and also mobile GPS data, again, generated by mobile devices. And these type of data, well, each of them have as pros and cons, but both of them can be used to basically investigate how people move across space and in time. So linking back to what Joachim said in the beginning, the first step is to understand where people live and ideally also how people move across space and how they use, for instance, services either at local level or at regional level. This provides really important insights that can then inform policies that are in charge of, for instance, planning service provision across different regions and within a country. Also understanding how commuting patterns are distributed is extremely important. And just to give an example, we are currently involved in a project, actually together with Joachim's colleague from G-Regio, where we want to better understand how to delineate functional areas in countries. So how can we delineate territorial units where people basically go about their daily life? And again, this is a very important piece of information that can be extremely useful when designing policies and also evaluating policies.
Yeah. Thank you, Claudia. Yeah, I wanted to bring up also the fact that for emergency responses, it's very important to understand where people are, and people are moving during the day. So those data sets from mobile phone may help us also in the future to provide something like a daytime and nighttime population that could inform better than the emergency response. There's still one question addressing Luca, and that was if ICLE is using EO data services to help mayors decide which hazards to tackle, and if so, which ones? You touched on this already a little bit, but maybe you can clarify this a bit more.
Yes, maybe just very briefly, and thank you also for the question. I mean, I think it's important. We are working more and more to make sure that we integrate also Earth observation in the data that are available for cities to do their planning and to prioritize actions also. But at the same time, we are trying to include these as one of the many tools that they should use when doing their adaptation transformative planning. So we are working on this on both the mission adaptation and the Covenant of Mayors. I want to say maybe just one example, because you were asking also of an example. We are working, for example, also with Google and the EIE platform, for example, to see how to map in different cities in Europe and beyond, how also the emissions, the tree canopy covering is affecting like the planning on climate action in cities. So we are trying to really integrate Earth observation into a broader discussion. I must say, this must be one of the elements that needs to be taken into consideration. Again, like involvement of population, of different stakeholders needs to be taken into account. So this is like one very important piece of the puzzle that can bring like closer also to the citizens of different stakeholders, the reality and the facts that then they will have to work on and prepare their strategy on.
Thank you. Thank you all. And I think we have run out of time. And I thank you all for your contribution and hand over to Stefan.
Thank you, Thomas. Thank you. And sorry for rushing you, but we have quite a packed program. So it's now time for me to pass the baton to Peter Dubin, who works at the European Centre for Medium Range Weather Forecasts. There are many things in common between ECMWF and JRC. One of them is science, like top world-class science, but science that informs decisions and that informs policies. And in fact, ECMWF is supplying several data sets that go into both flood warning, wildfire, early warning, etc., products of the Copernicus Emergency Management Service. So Peter is the head of the Earth System Modeling section of ECMWF. In fact, I remember we met a few years ago when he was already in charge of AI and machine learning, and obviously these new technology, the level of maturity of these new technologies is of key importance in order to further improve our ability to get better weather forecasts and better forecasts in general that inform, again, both floods, wildfires, and droughts. So Peter, the floor is yours.
Thank you very much. I hope you can see my slides and you can hear me well. Please shout out if not. But
yes.
Perfect. I'm going to talk about new developments, but basically with science and machine learning for weather forecasts. But before I go into detail, I just wanted to stress one point. And if you kind of want to remember one line really from this 10-minute presentation, it should be that at the moment, really, Earth system modeling is kind of really experiencing quite a disruptive change in a sense. And that basically means that there's a lot of things happening right now, but it also means that there are great opportunities for us really to kind of get better forecasts in principle. And to make this clear, I just wanted to start with one slide that many of you have probably already know. So that's a figure here that is showing how the forecast accuracy at the European Weather Centre kind of increased over time. The different colors are kind of different forecast lead times from 3 to 5 to 7 to 10 days. And what you should see is that all those lines are going up, and they go up for the last, like really literally the last 4 decades in terms of the forecast quality. And that's often what we call the quiet revolution of numerical weather predictions, that we really were able to kind of improve kind of the constant improvement over time about the weather predictions that we have by basically kind of having more observations, better observations, by using better methods to kind of get them into the mix, by using better models in principle, also go into higher resolution and so on and so forth. We were able to kind of get better and better over time. And then there was a second revolution, which we call the digital revolution. And the idea here is that you basically, you have supercomputers and you go from left to right here, kind of from the megaflop era all the way to the exascale era, and you kind of get more and more kind of capable supercomputing facilities. And then you can actually also increase resolution from 250 kilometers to all the way to 10 kilometers at the moment, and soon maybe 1 kilometer. And this kind of also kind of allowed you to kind of build better models that were able to resolve more properties basically in the system that you see in the vertical here. And that's what that was kind of fueling the process as well, to a large extent. And now we were kind of hitting a bit of a problem there, because we really had to kind of invest a lot of kind of software engineering, a lot of performance optimization to kind of really be able to kind of get the best out of the latest generation of machines with GPUs and all these kind of things. And therefore we had what we call the digital revolution as well. So now there's a kind of step change that happened in the last 10 years really to kind of be able to kind of rewrite your models to some extent to kind of be able to really leverage the capabilities of the latest generation of supercomputers. And again, this kind of worked kind of quite well, and it actually worked in a sense that we are now able to perform simulations in what we call the kilometer scale. And there are big projects like, for example, Destination Earth, where we basically kind of really build what we call digital twins. So the idea here is that the models are becoming so realistic that you can't really distinguish them from the reality. And also that you then have like a digital laboratory that where you can really try out different things. For example, what's happening if the Amazon rainforest would suddenly be gone, for example, and you can then really kind of understand what the system, how the system would respond to these kind of things. So this slide is basically to show you some nice pictures, and I hope the videos come out well. But basically the takeaway here is that these conventional models are really kind of quite fantastic in the sense that they go to kilometer scale. They really have all the details like sea ice cracks and these kind of things. The interaction with topography is kind of quite breathtaking, really. And we are able to kind of run these simulations nowadays, and we are kind of happy with this. However, this talk can't go on without also mentioning machine learning, as you probably all were expecting this. And here it's kind of really where it's also becoming a bit more disruptive, even more disruptive than the digital revolution. So in 2018, kind of we started thinking about how machine learning can be used for the community. And the big question was really like, can you do entire forecast models from machine learning? So the idea here is that you take reanalysis data as we use it, as we kind of produce it in DSNWF as well, like the ER5 and your ER5 reanalysis data set. And you have like a long time period of the atmospheric dynamics, like 40 years. And then you kind of just learn to update one date to the next using machine learning method. And this is kind of something that we looked into at DSNWF as well from the start, but we're always thinking about this as a toy model, as a kind of a toy thing to kind of explore, because it can never really work, right? And the time shows actually that it is working, and not even only that, it's also showing that technology companies like Google and NVIDIA and Huawei and actually other players are really kind of have been pushing this in the years between like 2019 all the way to 2022, for example. And this is kind of, they have been very successful. And I show you here the most scary plot that I've seen in the last 5 years. It's quite a boring plot in principle, but what it shows you is basically the forecast accuracy, as it shows you on the x-axis the lead time in days for the forecast that you have, and on the y-axis all the different parameters that you have, also on different pressure levels. And whenever there's a blue dot here, this means that the machine learned forecast model of Google is better than our EasternLF RFS forecast and deterministic predictions. So it basically tells you like most of the quantities that we predict in forecasts, like root mean square error scores, are actually kind of better in the machine learning world. And this was the Google Christmas present in 2022 to us and the community. And the community, first of all, responded saying like, yeah, but it can't really actually work. And there are all sorts of problems with these machine learning models. They aren't physical, they are black box, and so on and so forth. And there are good reasons to believe this. For example, that the forecasts are smearing out over the forecast lead time. So here you see basically a snapshot from the truth on the left, the ER5 training data set that we used. from 0-hour forecast to the 72-hour forecast. And on the right, you see one of those machine learning models, and you see that they're smearing out over time and losing small-scale structures. So that can't really be very useful for numerical weather predictions, you may think. So we used basically the time last year to really understand a little bit better what these models are doing. And to answer those questions, like, can we, for example, avoid the smearing character for long predictions? And the answer is yes, we can. We can actually kind of build on certain ensemble simulations and use generative machine learning, and we can actually get rid of the small scale effect. Can you represent uncertainties? Yes, you can. You can build ensemble systems as well and ensemble forecast systems and simulations. Can you explore things like extreme events with these models that are trained on the bulk of the weather? So why would they be able to actually kind of represent extreme events quite well in the system? And the answer is they are surprisingly faithful and surprisingly well actually in kind of also representing extreme events. So again, it's something like, wow, this is kind of more useful than you may expect in the first place. And then another question is like, are they physically consistent? And also here again, I mean, we're looking into this forecast now since 1.5 years or something like this on a daily basis, and we don't really see unphysical behavior in that sense, right? So they are also kind of quite physically consistent. And the last question on the list is, you can do forecasts now, but can you also do data simulation? And that's still to be answered to some extent, but the first papers that appear and also the work that we're doing in-house in data simulation is also very promising. So there's something in this kind of machine learning environment. How do we respond to this as a community? Then suddenly Google is kind of showing up and showing results that are competitive with your forecast system. The first thing that we've done, we basically try to understand more better what these models are doing. So we were running them in-house and really kind of looking into the results and looking how physical or non-physical they are. And this is, for example, a paper that we published in July last year to kind of summarize all these things. And the summary basically means that these models are also good for extreme events and actually kind of quite trustworthy. Then the next step is that we kind of running these models in-house on a daily basis, and we actually put the results also on the webpage. So if you want to look into a machine learned weather forecast, please go to our forecast page, and you will find basically forecasts that we perform into the future with several different machine learned models. So that was in September. In October, we actually also revealed that we're building our alpha version of our own machine learned forecast system, the so-called AIFS. And we are now basically also kind of reaching competitive stage. You can not really playing with the big boys in terms of the forecast scores as well. And we're quite happy with the results so far. So a lot has happened in the last year, and this has been quite disruptive in principle. But at the end of the day, this basically means that we will be able to provide better predictions. Just one more thing that I just wanted to show you in terms of the physicality of the systems. The big question is still like, can you also do like long-term predictions, like climate predictions, for example, with a system that is kind of trained on the past 40 years? Can you look more into the future and what happens if the climate is changing? And we just have a paper out where we kind of investigate this. So what we see here is like three different strands of simulations, one at 1955, one at 2023, so nowadays, and one at in the future in 2049. And you see the different climate states basically from the mean temperature. And then we use the machine learning model to look into forecasts and see how they behave. And what you see is this plot here. It's what we call the Harry plot. And what you see is basically that the models have a clear trajectory. For example, in the warming climate, they clearly go downwards in terms of the temperature. So you can clearly see that they're not really kind of adjusted to this kind of environment of the warm temperature. However, you produce actually very good results. So the models are resilient in terms of the weather forecast even in the future, but they still have a problem with basically kind of the attractor of the warm world. You kind of there will still be some work to be done to actually kind of get this working in the bigger picture. And next step, so you can argue like what's going to happen in the next 5 years if the last 5 years have been so exciting. And I think one big step that is going to change soonish is that we're going to go more towards what we call a foundation model. So if you have all those application areas where you can potentially use machine learning in the numerical in weather and climate space, basically, and a lot of these applications are, I guess, also very interesting for this community here, with renewable energies and food security and kind of also looking into extreme events and these kind of things. You can argue like, is it actually possible to build like not 22 individual tools here, for example, but just one tool that can basically be used for a lot of applications? And that's what we call a foundation model. And there are first climate results out that show that these foundation models actually kind of perform very well. And we now have a project that will start in February, a Horizon Europe project that is called Weather Generator, where we will be basically able to kind of build one of those big foundation models. And the idea here is that you, in the end, you have a tool in the middle, basically, that will be able to use whatever kind of data set you give it, whether it's reanalysis data, simulation data, or observations of all sorts of kinds. And this weather generator will give you like a probabilistic mapping to all sorts of data that you may be interested in. And this could then be used for all sorts of different applications like nowcasting, medium range, but really also data simulation, and also in the high impact sector applications like energy output, extreme events, and so on and so forth. So I think if you are interested in the future, this may be a good option to kind of put your bet on. I don't know exactly. The field is so complex and so fast moving that it's difficult to kind of really say what's going to happen. I still tried this on this slide here. So this is kind of my one-page summary that is going to be totally embarrassing in 2 years to kind of look back. But I think so far we have seen that machine learning models are really kind of coming into the weather domain since 2018. People were focusing on hybrid models, like combining machine learning with conventional models. That looked into nowcasting because it's not so dangerous to kind of get things wrong there, in a sense that you don't really need too much physical consistency as long as you kind of in the observation space and so on. But then kind of really machine learning showed that they are better than deterministic forecast models in the forecast scores. They showed in last year that they're better in ensemble simulations as well. They were the first AMAP simulations, so you can run atmosphere models for like 20, 30 years and stably into the future. But they were still kind of uncoupled, so not quite climate simulations. This year, we will basically see that data simulation is going to kind of be really doable as well with machine learning. And the next steps is then that you can have also go to more like an Earth system model. So you will have an ocean component, a sea ice component, a wave component, a land component in those systems. And then in 2 years, you probably will see that some groups will actually build climate simulations. I'm not saying that these climate simulations are going to be satisfying for everyone in the community, because they will always have this problem that you can't really extrapolate in the future. However, there will be those climate simulations, and they will kind of perform well on today's diagnostics, and will also make a dent in the future, whoever is believing in them. And then there's going to be this push as well to foundation models. So that's all I had to say. This is my summary here. Please don't. It's very, very kind of high level. I think the important part is that we had those 3 revolutions, and the machine learning revolutions in particular have been quite disruptive. And the next steps really will be that the models will become better. The tools will be easier to be used as well. And we probably also need to talk a little bit more about like federated data, because that's really where the machine learning capabilities are kind of really very important. Okay, thanks a lot.
Thank you, Peter. We'll take a couple of questions before the last keynote. Here we are. An anonymous question says, you mentioned the increased spatial resolution of your models. With a kilometric scale, do you take into account also the shape of settlements that could be provided by the CEMS exposure component, the CEMS, I guess?
So yeah, very good question. So the shape of settlements is maybe a bit too much to say there, in the sense that what we do is we have an urban model, and we kind of really have also like an urban scheme in there. It is kind of comparably simple in a sense. It's not like there are urban models for limited area models that are much more sophisticated, basically. But we take this into account, and we also see, for example, urban heat island effect and these kind of things. So the answer is yes. However, if you talk about small settlements, I'm not quite sure whether we will represent all of those in the system. We basically kind of start from the data sets we have. So also there, probably yes, the data sets could be useful.
And the other question is about the environmental impact of all the computers required for these models to run, impact on water, impact on energy. What can you say about that?
Yeah, it is. There's an environmental impact. There's no question. These the biggest machines, they use megawatts of energy. You have this impact already to some extent, right? I mean, numerical weather predictions was always a high performance computing application. And machine learning, to some extent, is actually reducing this right now, in a sense that you can run a machine learning forecast on a couple of GPUs, where it's kind of the conventional forecast is kind of done on hundreds of GPUs. So it is a bit of a trade-off, but I do agree that the training in particular is the training cost is exponentially increasing right now. In that sense, there will be some imprint on the resource demand as well. So I can't claim that this is a a green project in that sense. I would personally hope that the benefits kind of outrule the impact there. And we're also kind of doing things like running on Lumi, for example, in Finland, that's kind of running with renewable energy and these kind of things. But at the end of the day, it is an energy intense mix. Yeah.
Thank you, Peter. So it's now time for our last keynote before the lunch break. And this keynote will be by Peter Salomon, who's the coordinator of the Emergency Management Service at the Joint Research Centre of the European Commission. He will tell us, and I'm sure a lot of us are interested in knowing what's new and what's up. Peter, the floor is yours.
Yes, thank you. Let me just go into the slide mode. Do you see my slides? Just a confirmation before moving on. Stefan, can you?
Not yet. We can see you, but not your slides, or at least I cannot.
Okay, let me just then try it again. Yeah.
We see your screen.
Okay, I go into presentation mode. Let's go back. Okay. Okay, I hope, please let me know in case there's still a problem with the slides, but now I'm aware that I'm keeping you away from your well-deserved lunch break. So I'll try to be as short and as precise as possible, but let me now show you a little bit what we are planning in terms of recent developments and upcoming service evolutions of the Copernicus Emergency Management Service. And I mean, already this morning we heard in between many of the talks some of the new elements that I will show here as well. Now, I think before talking about the future evolution, it is worth having a look back quickly. The Emergency Management Service is operational. It was one of the first Copernicus services to become operational in 2012. We had only two components, the on-demand mapping and the flood early warning with the European Flood Awareness System. But over time, in the coming years, as you can see here on the slide, we added the component on forest fires, then droughts. We expanded to the global scale, in this case for the global awareness system. We added also the exposure mapping component. And even inside those components, we, as you can see on the right-hand side, these are just examples, we continuously try to work on making the products and the service that we provide better through scientific developments and improvements. One thing that I should also mention, that some of the work that you see here today in operations is really based on work that has started well before 2012, work on forest fires, on floods. And we also have, of course, a strong link, and I will come back to that later, to research projects. In particular for the on-demand mapping, the SAFER project was really fundamental. Now, what are the basic principles when we try and evolve the service like the Emergency Management Service? Like the entire Copernicus program, we are very much user-driven. You've heard that also in this morning in many of the panel discussions. So collection of user feedback is fundamental for the evolution of our service, in particular from our key users. And this is, for the emergencies, of course, the civil protection authorities, but as well our colleagues from the Emergency Response Coordination Center. A second pillar is, of course, the internal research and development that we do at the JRC. Most of you know that JRC is providing scientific policy support, so there's a lot of work ongoing. And we of course do use this internal innovation and research also to drive the evolution of CEMS. Another element which is really important is interaction within the components and with the other Copernicus services. We've heard this morning the linkage for pre-tasking of the on-demand mapping between, for example, the flood forecast and the on-demand mapping. But we also use, of course, data and information coming from the other Copernicus services, or provide information, for example, from our hydrological models to the marine service, or as we've seen already, we make a strong use of ERA5 or the seasonal predictions coming out of the climate change service. Then, of course, international collaboration and research projects are a last but very important element also for new evolutions for the emergency management service. So working together with, in particular with UN agencies, in our case, WMO, World Food Programme, but also with the other space agencies is really important when talking about evolution of the emergency management service. And last but not least, linking to research projects. After lunch, you'll hear about 3 of them currently ongoing, and all of the 3 have elements to try and work and improve the products and evolve the services that we have as part of the emergency management service. So make sure after lunch you tune in and learn about SeedF, Centor, and OverWatch. There has been, from our colleagues of the Knowledge Center of Earth Observation, an effort to really have a strategic outlook on research and innovation, and this is shown here in the report and on the right-hand side. If you don't know it, and if you are interested, this includes a lot of the information that I will show you here today. But also for the other services, have a look at this report. It's really quite interesting. Now let's move a little bit into the real evolutions that we're currently planning, and of course, key of also of the other Copernicus services, same as for the emergency management service, is the usage of satellite data. So integrating new data sources is fundamental. Is something that is often forgotten, but this is being done in the background. Most of the users don't notice it, but it is requiring a significant effort. We've heard there's a new Sentinel-2C was launched in in 1 month, 1.5 months. Hopefully the new Sentinel-1C will be launched. So we will work on integrating these directly also into our products of the emergency management service. But then we make, of course, use of all the new satellite data, which is coming also from private space companies, and that is accessible to us through the Copernicus contributing missions. Or we are even looking beyond, such as Meteosat 3rd generation, which will be fundamental also to improve our forest fire monitoring. But there's not only satellite data that we are continuously adding to the CEMS products. We have heard this morning about the importance of aerial data. This is something that is relatively recent in the emergency management service. But we are collecting also data coming, very high resolution LiDAR data, in particular of the digital elevation models that are available from the national member states, to improve also the products that we provide, in particular of the on-demand mapping. We use census grid data. You've heard about the exposure mapping component. This is fundamental also to further improve our estimations of where populations live and to improve these types of data set. And last but not least, of course, we also need in situ data. In this case, I've shown the example here of meteorological or hydrological in situ data, which is really important for our prediction when it comes to floods, forest fires, and droughts. Now, of course, we work on the second element is of course evolving the existing products and adding new ones. I've put here a couple of examples on the early warning and monitoring component. You know that we are constantly upgrading our forecasting systems, similar to weather forecasting systems. So we are planning major releases of the European and global flood awareness systems, as well as our satellite-based global flood monitoring system next year. And to add possibly also a new coastal flood early warning product, because currently we're only covering riverine flooding. For droughts, similar in the floods, also here we are continuously evolving key indicators and products for our drought observatories. The combined drought indicator, we are currently at version 4, is constantly being evolved. We're adding now also a drought impact database, and recently have added information on drought risk, which is in particular important for the prevention phase. And we're looking at enhancement of our outlook, so really improving drought forecasting when it comes to using from subseasonal to seasonal to decadal forecasts. And last but not least, of course, also when looking at forest fires, also here a new mapping of wildfire severity has been recently included to better evaluate environmental and economic damages. And we're working on improving the near real-time detection and mapping of active fires. Also here we get new sensors like VIRS that we are trying to optimally use to really further improve the burnt area mapping. The on-demand mapping components and exposure mapping components obviously also see evolution of their existing products. We've recently added flood depth. When you're activating the on-demand mapping component for a flood, you will receive now not only the extent, but also the flood depth. And we're working on expanding also here a little bit our maps into, in particular, the urban areas, which we all know are fundamental, are key when it comes to impacts. But unfortunately, it's most of the synthetic aperture radar satellites that I often used for flood mapping have issues when it comes to urban dense areas. Now, we are also looking at expanding our pre-tasking concept that we have for the floods to large intensity fires, and improving timeliness overall of our products coming from the on-demand mapping through improved data access and faster workflows. And of course, for the exposure mapping, you heard it already, we are going to have an operational production of the global human settlements layer, so every 2 years. We're looking at regional versions or improved characterization of building stock, and even trying to disaggregate population information by sex and age. And this will all be very valuable when it comes to better characterizing the impact of a disaster. Now, let me also say a couple of words on artificial intelligence. And this is, of course, something also important for us for the evolution of the emergency management service. We are working already on some elements here. I've put here a couple of points down. You heard this before as well. We are looking at using parameter learning and machine learning-based regionalization techniques for our hydrological models, so improving the flood and drought early warning systems with machine learning, trying to use AI to detect, monitor drought and heat waves, or analyzing satellite and drone images for emergency response. These are really ongoing evolutions and research that we're trying to integrate into and bring into full operations. I promise I did not talk to Peter before. Also, foundation models are for us something that we see on the longer term as quite promising. This is far still from the operationalization, but I do think that this is also an element that will be important, increasingly important of the emergency management service, and hence linking to activities or like Destination Earth is, of course, also for us of utmost importance. Let me come to an end because we all like to talk about, technology, science, but in the end, as I said, EMS is a very user-driven service, and evolution needs to take place also when it comes to accessing the data and providing better user support. I would recommend you all having a look at the latest, at our new webpage of the Emergency Management Service, which provides really a nice overview with use cases and that we will further continue to add to explain what we do, how we do it, where you can access our data. We've added also new web portals for the drought observatory systems. We have improved the statistics portal that you've seen from Jesus this morning. It's really fantastic statistic, really informative. You can have a look and generate them for your own area, for your own region of interest. And we are continuously working on improving this type of user support, so really being transparent and open about the information that we provide. We will work also on a national collaboration program, so really to work on improving the capacity building. And last but not least, of course, data access, as I mentioned. We've just released the early warning data store with the help of the climate colleagues from the Copernicus Climate Change Service, and also integration of the SEMS data sets into the Copernicus data space ecosystem is something that we will be working in the coming months and years. So I'll stop here. I thank you for your attention, and I'm ready for questions if you're not yet too hungry for questions.
Thank you, Peter, for this exciting overview. Really looking forward to seeing all these new developments becoming operational. There is at least one question. How does new research project connect to SEMS services and ERCC in project activities? Are there established mechanisms for this?
Yes, so there are specific Horizon Europe calls that concern the evolution of the different Copernicus services. And there is regularly, in particular, also evolution of the emergency management service. There are research calls ongoing. SeedFD, as I mentioned, is one of those projects, but also Centor. And there will be in the future also more Horizon Europe projects coming up that are really directed to specifically to the evolution of Copernicus services.
Then a colleague is asking where we're going to share all the slides, and the answer is obviously yes. And the recording of this session, of this entire annual meeting, will also be posted on the YouTube channel, the EU Space YouTube channel. I see no more questions, so I think it's time for a lunch break. As I guess none of them had made a reservation in a gourmet restaurant, I suggest that we do reconvene at the originally scheduled time, which is 2 p.m. So thank you again to the more than 200 people that have been with us for three and a half hours now, a bit more, no, close to 4 hours. Really interesting discussions and interesting information, and looking forward to seeing many of you back at 2 p.m. Thank you. Congratulations, indeed. Impressive to see that you nearly got them all right. So it is time, in fact, to go to our next point. Before we do that, because as we were running late, we did not have time to present one item, which is the atlas I'm talking about. A new edition has just been released. It's the Atlas of the Human Planet. It's the 6th edition, and it provides an unprecedented view on 50 years of population growth and urbanization trends across the world. It's a mine of information, so I invite you to download it at the address that my colleagues will put into the chat, or to make a picture of the QR code before we move on to the next session. So the next session is about how can research, European research, EU-funded research, how can it help SEMS to better address user needs, or to fill in gaps that the technology and the science could not fill in the past. There are regular calls under Horizon Europe, the EU funding mechanism for research, which are addressing service evolution. And there are several projects that are underway currently, which indeed address this evolution of the service, looking into either new areas, such as coastal flooding is a good example, or just trying to advance the level of either temporal or the accuracy or the resolution or the probability that a prediction will be correct. So there's quite a number of these projects, and we will be looking at 3 of them. The first one is called SeedF.
Okay, I'm starting.
Yes, please. Thank you, Vanessa. Sorry for
Okay,
this.
thank you. No problem. So, good morning, everybody. I'm Vanessa Pedinotti from Magelium, and I will be presenting the SeedFD project's objectives. So, SEED stands for Strengthening Extreme Events Detection, and it's an initiative under the Horizon 2023 framework, specifically within the CEMS program. The project started on January 1st this year, and it will last for 3 years. We are committed to making impactful progress of emergency management over the years until 2026. So first, I'm giving you an overview of the consortium, which is gathered people from all over the world, but mostly Europe. We at Magelium are the prime contractor, and will be helped in this mission by ECMWF, which is the science leader. We've also got partners from Italy, Austria, France, Germany, and then we've got a partner from a governmental authority in Kenya, which is called ICPAC, which is on the field and will help us to validate the developments. So this project, the mission of the project is to enhance the Copernicus Emergency Management Service for floods and drought, ultimately delivering robust hydrological extreme forecast worldwide. So the underlying issue behind the project is about being able to monitor and to forecast continental water dynamics at global scale for the detection of floods and droughts, which unfortunately, as you may know, are becoming increasingly frequent. And forecasting these events necessitates the use of models and the ability to get data, robust data that describe the processes and help us to validate the models. So traditionally, in situ discharge observation have been invaluable for this purpose, but as you may see on the map here, their ability is here on the map, all the dots represent in situ discharge stations, but unfortunately, many of them are no longer operational. And this issue is particularly prevalent in the global south. If you see the map, all the red and orange dots are stations that are no longer operational. And forecast continental water dynamics effectively. So in terms of floods and droughts forecasting, the CEMS service plays a crucial role, but it has its own limitations. And the SeedFD project will address 3 CEMS early warning system critical gaps, taking the opportunity of the daily delivery of millions of hydrological relevant data across the world by the Copernicus space missions.
Sorry, Vanessa, but
the first gap
seems to be playing games with us. We don't see your presentation.
Concerns the models and the fact that they do represent processes, but these processes are very complex and represented in a very simplified way. When they are represented, the core of the CEMS early warning system is the list flood model, and the list flood model was originally developed for European application and does not yet resolve all the many complex processes that can be found in data scarce regions such as wetlands, reservoir operation rule, groundwater flows, or evaporation and specific routing. The second gap comes from the disconnection between the increasing availability of satellite data mostly, and the fact that these data are underused in the CEMS early warning system. They are not used, for example, for model improvement, like representing better processes or for calibration, and they are not used for real-time correction through data assimilation and post-processing. And finally, the third gap comes from the fact that in our common perception, floods and droughts are unique phenomena, but in reality, they can come from many different sources, and they can be of many different types. They can be river floods, flash floods, meteorological droughts, or hydrological droughts. And the CEMS portfolio, while comprehensive, still lacks some real-life event products that can capture the multifaceted nature of these occurrences. So SeedFD will add new flood and drought products to the CEMS portfolio, ensuring that our emergency management service is equipped to address the complexities of the different events. So just to precise or to be clear, SeedFD is not here to replace CEMS, but rather we aim to collaborate and build upon its foundations by addressing these gaps. And the project wants to strengthen the CEMS capabilities. And from these gaps that I just explained, we can identify three specific objectives. The first one is to enhance the CEMS hydrological model for better representing the range of hydroclimatic processes worldwide. The second one is to demonstrate the added value of using information from satellite data, innovative in situ microsensors for high quality simulations. And the last one is to expand the CEMS early warning system portfolio for floods and droughts. The work logic of the project is divided in several work packages and in two phases. The two phases there is a first phase of the project, which is a science development phase, where we will do all the developments, the implementation of the calibration, data assimilation system, the model improvement, and new products of floods and droughts. This will be done on two development basins, which are really well instrumented. And then there will be a scale-up evaluation phase or a demonstration phase where we will try to demonstrate the applicability of the results on different basins of the world, which are undergauged or less in data scarce regions. Here you can see the study and validation basins. So the two development basins are the Danube basins and the Bima basin, and the three validation basins are the Niger, Juba Shebele, and Parana. And there will be also specific validation case of the new flood and drought indicators on in the world, on a world scale. Just to present you the SeedFD project on a map, so you can maybe have a clearer idea. So we are 9 partners from all over the Europe, mostly with strong expertise in hydrological modeling, extreme event detection, data analysis, data assimilation, and we've also get the chance to have several researchers helping us, giving us advice through the project, who are experts in Earth observation and hydrological processes. The two development basins are the Danube and the Bima basin. And then we've got 3 validation basins, which are the Niger, Juba Shebele, and Parana. So this will help us to address the specific issues of the gaps that I explained, but also to see the global scalability of the project. For communication, I invite you to see our website. We've got a website online, which was launched at the end of this summer. And we've got also social media in which we give more information about the project, about our specific objectives, and about the advancement and progress that we are doing, or the publications and communication that we do. We've also got a flyer that is available online, and you can download it if you want to have all the details, or the details I gave in these presentations are gathered in the flyer, and if you want to communicate about the project. And we are also organizing a workshop in February 2025 to allow all the partners to gather, to conduct an initial collective assessment of the project, to address the potential issues, and most importantly, develop clear perspectives for the continuation of the project. It will last 1 day and a half, but half a day will be dedicated to presenting the initial results to local stakeholders from the Danube Basin. So if you are interested, or if you know people who are interested, you can let us know, and we can invite them to the workshop. It will occur in Austria at TIASA Institute in Luxembourg. And I will finish with the outcomes of the project. The idea is that everyone, everywhere in the world can be protected by an early warning system. And this will be valuable for local authorities, water security and humanitarian agencies, which will benefit from the real-time and quantitative global forecast of floods, but also of droughts that will be provided by the system. Scientists will also have access to new or improved tools for hydrological modeling, data assimilation, data processing, and so on. There will be also a better synergy between the Copernicus services and all the data sets that are available on these services and the forecasting chain. And also, the real case study will help us to raise awareness of flood and drought prevention with a wider audience. And that's it.
Thank
if you
you.
Have questions, I don't know.
Thank you, Vanessa. Let's see if we can take one quick question, if there is a question. But a real quick one. There mustn't be any, otherwise it would be displayed. So thank you again. We're going to move on to the next presentation, which is a presentation by Simone Riccardi from Igeos in Italy, which will present the Centor project, which is a project looking at the evolution of the
I cannot hear anything. I don't hear you.
Is everybody not hearing me?
No, I'm hearing you, Stefan.
Okay, sorry. So Simone, the floor is yours.
Yes. Do you see me? And
we see you.
Yes.
We don't yet see your presentation, but we see you. We were seeing you we see your PowerPoint.
Okay, let me introduce in presenter mode. Okay, do you see the full screen?
Yes. I ask all the presenters to please stick to the time allocated and to leave some time for the questions. Thank you.
Okay. So good afternoon. Today I will show you how the Centor project is advancing CEMS by addressing climate change challenges and improving our ability to handle complex emergencies. As you know, climate change has caused extreme weather disasters to increase fivefold in 50 years, with major floods doubling in the last 20 years. The project aims to tackle these challenges by developing new components for Copernicus EMS and Copernicus CESA. Its key objectives are to improve situational awareness and preparedness in response to climate change's effects, and to anticipate crisis events triggered by climate extremes. The Centor project focuses on improving CEMS through a variety of operational benefits, particularly related to flood threats. Urban flooding is being enhanced, including the integration of a prototype urban flood layer within the European Flood Awareness System, viewer, and a new early warning system is being developed, which enable more accurate predictions and more comprehensive assessment of flood risks in urban areas. Moreover, Centor also strengthens the geointelligence services, which allow for the proactive monitoring of social unrest, population movements, and conflicts, all of which are increasingly tied to food and water insecurity. The Centor project is organized into several phases, with critical groundwork laid before moving into the more operational stages. Before entering the cold cases phase, currently ongoing, we first defined 5 key use cases, which provided a framework for understanding the diverse contexts in which Centor services would be applied. Following this, we developed a set of 33 innovative indicators to address specific challenges, assessing urban flood risks, socioeconomic vulnerabilities, and water and food insecurity that will feed a dedicated online platform that is being developed. Currently, Centor is in the cold cases phase. It is utilizing a well-documented past crisis to calibrate models and validate indicators. This phase will conclude with an end-user workshop in the late November, where feedback will be gathered to refine the models and indicators. Following this, the project will transition to the hot cases phase, applying Centor services in the real-world high-risk areas. So the Centor project operates through a structured workflow that mirrors the phases of the Copernicus Emergency Management Service, specifically focusing on the stages of early warning, the alert system, and the monitoring. These stages are critical to ensuring timely and effective responses to climate-related emergencies. The project starts by collecting, the workflow starts by collecting input data to produce indicators like the flood extension and flood depth, which provide detailed data on potential risks. These indicators are then combined into indexes to offer a broader understanding to threats. Centor enhances situational awareness by providing early warnings of potential crisis, allowing decision makers time to prepare. So if the thresholds are crossed, alerts are triggered, quickly sharing critical information. And finally, the real-time event monitoring continuously tracks and assesses risks, ensuring a dynamic and effective response to evolving situations. Centor notable innovation is the Urban Flood Early Warning Forecast Index. This index integrates 3 key indicators. As you can see on the left, we see the indicator 2, which predicts the probability of extreme precipitation events with return periods of 10, 20, and 50 years. And on the right, you can see the ED3, the indicator 3, which provides high-resolution urban flood maps showing both the extent and depth of inundation for the same return periods. This is developed using a geomorphological model. So these tools bridge the gap between the meteorological forecasts and high-resolution flood modeling, offering a more accurate and timely insights into flood risks. Moreover, with a 3-day lead time, they give authorities and emergency services sufficient opportunity to mobilize resources and mitigate potential damage before floods occur. This index incorporates also an alert system that will trigger the following phase of event monitoring. On the left, see a risk matrix that helps us determine the appropriate warning level based on the probability of extreme precipitation events and their return periods. This dynamic matrix moves us from low-level warnings, that you can see in yellow, for more probable but less severe floods to up to an high-level warnings in red for rarer, more extreme events with significant impacts. So a warning is triggered when the likelihood of extreme precipitation around the area of interest is low or higher, according to the risk matrix generated. Each level of warning is associated with an inundation map represented by the UFED3 on the right that shows the potential impact of the extreme precipitation event, highlighting areas likely to experience significant flooding. Once an extreme event, weather event is forecasted, the system initiates a detailed monitoring at both regional and local levels, producing relevant indicators. At the end of the event monitoring phase, the Flood Impact Index, FEI, is generated, assessing the extent of damage caused by urban floods. The FEI is based on a linear formula comprising 5 innovative indicators, each weighted according to the vulnerability of the affected area. The output is a special matrix that categorizes impact into 3 levels for the event affected cells. On the right, you can see the UFED5, one of the innovative indicators developed during the cold cases for the Spanish use case. And it is a key component of the FEI. It is known as the Urban Flood Damage Assessment Indicator and addresses the limitation of a traditional SAR satellite imagery in detecting urban floods. It provides comprehensive flood mapping, including flood extent and flood depth in urban areas, as well as a detailed damage assessment for both residential and non-residential buildings, along with the infrastructures like roads. The FEI also incorporates the vulnerability composite indicators, okay, you can see on the left. These indicators include distance to the distance to the nearest fire station, the average income, and the accessibility by road. The social vulnerability score is derived from factors such as income levels, access to the essential services, and evacuation challenges, with each component given equal weight. Additionally, the flood hazard indicator on the right plays a crucial role by utilizing web-based data to assess extreme flood events. It provides an hazard characterization for specific areas, offering valuable insights into historical flood impacts. This aids in flood management strategies and helps evaluate the severity of future events based on the past occurrences. So, Centor wants to enhance CEMS following a complementary approach with the current state of art, addressing operational gaps, particularly in urban flood mapping and global weather forecasting. To this end, it utilizes georeferenced traditional and social media data alongside LiDAR-based, which are digital terrain models, to improve flood delineation. Additionally, Centor enhances global weather forecast systems, allowing for more precise prediction of intense localized events and improving the pretesting procedure. This enables satellite imagery to be ordered in advance, allowing for immediate data analysis once an event occurs. The integration of urban flood mapping with SAR data provides users with accurate information from the very first products, bypassing the need to wait for optical imagery. This leads to faster damage assessment, accelerating information delivery by several days. So I'm concluding. The Centor project is set to play a pivotal role in enhancing the Copernicus emergency management service. And in this slide, you can see a summary of Centor's complementarity with CEMS. So with that, I wrap up the presentation, and if needed, I leave the floor open for any questions you may have. So thank you.
Grazie, Simone. Thank you for sticking to the timeline. Any question? No, apparently not. So we'll jump to the last keynote on the research projects, and I'll give the floor to Davide Elisi, who's a GIS analyst at Ithaca in Italy, and will present the OverWatch projects, which deals with improving the support to crisis management for wildfires and floods. Davide, the floor is yours.
Yes. Can you hear me?
Yes.
Can you
Not
see the presentation?
Not yet.
It should be sharing. Let me try again. Okay, can you see it now?
Yes. Not in full screen, but we can see it.
Okay, can you see it now in full screen?
No, we can see the presenter mode.
The presenter mode, okay. Okay.
Now it's fine.
Now it's fine? Can you
Yes.
see it?
Yes.
Okay, perfect, thank you. Okay, so I will start. Good afternoon, I'm Davide Elisi, I'm from Ithaca SRL, and I'm going to briefly present you the OverWatch project, which is a project founded in the context of the Horizon Europe program under the call EUSPA 2021 Space, and I will show you some of its development in the last 2 years. Okay, so in a nutshell, the OverWatch project objective is to implement a crisis management system focused on wildfires and flood events powered by Copernicus data. The crisis management system will be used to improve and secure communication among emergency operators, and it will also provide some useful information to better inform decision makers. As you can see in the slide, I'm mentioning some key technologies which are involved in the system, which are Earth observation data, data acquired from drones, as well as artificial intelligence for data processing and augmented reality for data visualization. Another key point of the project is that it's trying to continuously involving end user through a human-centered approach. And in fact, in the 3rd year of operation and development, there will be 2 pilot demonstrators that will be pivotal to test the system under real conditions. So this is the current status of the project. The project lasts for 36 months. The project started in November 2022, and therefore we are now at month 24. We are entered the 3rd year of operation, of development, and you can see on the right the partners of the consortium. We have 10 partners from 5 different European countries, and we have representatives from small, medium enterprises, as well as research and technology organizations. Ithaca has the role of a coordinator in the project. So here I'm showing you a slide with the architecture of the OverWatch system. We can split the architecture into sections. We have the services and the platform, let's say. In the services, we have all the modules which pertain to mission management, to the fallback connectivity network, and all the modules that pertain with the mapping from Earth observation data. Something is happening. Okay. Okay. Can you see the presentation good now? Okay, I will continue. So on the
no, David, sorry, we are still seeing your notes.
Okay.
So maybe you should invert the screens if possible. Sorry if I interrupt you.
Okay. So this way you see the notes.
Yes.
Okay, but if I invert like this, you still see the notes, right?
Yes. Apparently, yes.
Yes. Okay. I will try to
Or if you want, we can share the presentation for you.
Sure. Sure. You can
Okay.
present it yourself. It's not a problem for me. Sorry about that. I'm not sure why it was doing that.
No, actually, yeah, we are having, as you can see, some problems.
With WebEx.
Yes. So, do you remember exactly which
slide was the project concept? It should be slide 4.
Okay, just a sec. Okay. The floor is again yours.
I don't see the presentation, but I can just go on, let's say, maybe. If other people can see it. Okay, now I see it. Okay, thank you. Okay, as I was saying, we have the modules which relate to the mapping from Earth observation in the OverWatch services on the bottom left, but we also have the modules which relate to drone mapping. We have a module that also, let's say, processes data using artificial intelligence. And on the right, instead, you have all the modules which pertain to the back end of the system. So we have some modules which are spatial repositories, data storages, the importers and mappers, map servers, as well as all the databases. But most important, well, all of this is connected through a management backend. But the most important part is that we also have the front-end modules, which are the AR front-end and the web-based dashboard. Okay, next slide. Here, sorry, I'm seeing. Okay, here I'm showing you 3 images from the last midterm review that was held in Turin in May. I'm showing you an image from a drone that is used by that will be used by the OverWatch system. This is a VTOL drone, which is equipped with a RGB camera as well as STEM cameras and LiDAR sensors. This will not be the only type of drone that will be used by the system. There will also be tethered drones, which will be used to provide a fallback connectivity network. These drones will be basically connected through a fiber link to the ground station and will provide a network to all the systems that require a connection in the vicinity, including the mapping drones. In the middle, you can see an operator using the augmented reality device to access the 3D holographic environment where the users will be able to visualize in a 3D environment all the data that is produced by the OverWatch system in a more immersive way, let's say. On the right, you can see a screenshot from the web-based dashboard, which is a more classical approach to data visualization, and it will provide the users all the updated data produced by the system. Okay, next slide. Okay, this is going more in detail on the EU mapping module. This is a general scheme of how the module works. We have a dispatcher that receives the map request, and the orchestrator then retrieves the necessary data through this sub-module here, the data retrieval. It will retrieve the necessary Sentinel-1 or Sentinel-2 or other types of data, geospatial data, depending on the type of functionality that we are analyzing. And then there is the EU mapping sub-module that will process the raw data to produce some outputs. These outputs will then be analyzed in the impact assessment modules, which will then send all the data to the backend, and which will then serve the data to the front end to be visualized by the users. So among its objectives, the OverWatch project is trying to improve the processing workflows that are ordinarily addressed within the rapid mapping services. So to try to speed up some of the procedures which are common in the rapid mapping service, but it's also trying to let's say, make use of the Copernicus Emergency Management Service data, which is freely available. And the use is that we are trying to train these deep learning algorithms through this data. Next slide. Okay, for example, for wildfires, we have trained 2 machine learning algorithms, one for delineation, one for severity of burnt areas. And as I said, we use the Copernicus Emergency Management Service annotations to generate these data sets that were then used to train these machine learning algorithms. We use basically the observed events which are produced from the Copernicus Emergency Management Service. And you can find all whole dataset at this link, or you can find it on the OverWatch website. The algorithm for the delineation was also validated, and you can see on the right an example of 2 activations that were used for the validation, which were not present in the training dataset. You can see on the left the Sentinel-2 image in 2 colors, in the middle the prediction produced by the model, and on the right the ground truth, basically the observed event produced by the operators. You can see there is good matching between the prediction and the observed event, and this is reflected in the metrics. For the 2 activations, we have very high values of F1 score and intersection over unions, as well as the processing times, which are, I would say, fairly fast, but of course depend on the size of the image. Next slide.
Davide, I will have to ask you to wrap up because we will have to move to
Yes,
thank you, sir.
Okay, this is just an example of wildfires. Here I have a post-event image, and you can see the burn area delineation, the active flames extraction, and the burn severity estimation, which are some of the products of the wildfires mapping. Next slide. And for what concerns flood mapping, which is another use case, we have 2 services. We have a continuous monitoring service and an on-demand service. Regarding the on-demand service, this is also a machine learning model which was trained using CEMS annotations. You can find the dataset here. It is based on Sentinel-1 image. So we take the 2 input images, 1 pre-event and 1 post-event image, and we train this. This has not been validated yet, but it is planned. And you can see an inference here on the left. You have this flood in Malawi, MSR 561, where you can see in blue the reference water and in cyan the flooded area extracted from the Sentinel-1 images. Next slide. Okay, so to conclude, basically, what is next? The OverWatch model, the OverWatch modules have been basically mostly developed. We are finishing the development of the modules. So they are being refined and validated. There is an effort in system integration to link all the modules together, and as well as an iterative fine-tuning phase. We are collecting usability feedback from end users, and most importantly, in the 3rd year of development, there will be 2 demonstratory events which are planned to be hosted in Poland and Portugal for floods and fires, respectively, which are the use case countries. These 2 demonstrators events will be very crucial to understand any potential criticalities and to test the system under real conditions in the real environment under real variables. Next slide, but it's. Thank you for the attention. You can find all the links if you have any questions or if you want to discuss further or find more about the project, you can write us for the websites or the socials. Thank you.
Thank you, Davide. Thank you, Davide. I am told there are no questions. Therefore, we will pass directly to the splinter sessions. So the splinter sections are organized as follows. We have 5 rooms which will be repeated twice with the exception of the wildfires. In the first round, the flood room will be hosted in this main meeting and live streamed, and in the round 2 will pass to the wildfire devoted room. So you've expressed preferences during your registration. You're free to change your mind and to go to another one. One point is if you experience difficulties in entering these rooms, just put in the chat that we have enabled, just put your name and the number or the subject of the room you would want to attend, and our backup team will do its best to admit you, but it's one by one, so it won't be really fast. A little message to the moderators of the splinter sessions. We have to end on time, despite the fact we are 5 minutes late. So thank you in advance for your cooperation. We'll see you after the second round for the closing remarks of this event. Thank you. So we have on this one, the flood maps. And I pass the floor to Peter Salomon.
Yes, thank you, Stefan. I give your people a little bit time to move in the relevant breakout sessions. In the meantime, I will ask my colleague Stefania Grimaldi, who will assist me a little bit in today's session to see if she is there and she can speak. Stefania, are you there? Can you hear me? Are you able to speak? I see Stefania.
Yes, I'm here and hopefully I'm able to speak. I'm able to speak. I hope you can hear me as well.
Yes, very good. Let me now, I will start sharing a little bit of content. And I will do that trying to share the full screen. And then see. That did not work, I think. I don't, there it is. Okay. Now, I'll go in presenter mode. Okay, Stefania, can you confirm that you see the slides and you can hear me well? Apparently not.
I see your WebEx screen.
Okay, you don't see the slides?
Yeah, no, I don't see the slides. I see what you see in WebEx.
Let me, maybe there's a bit of time needed. Let me see. Maybe I pause sharing and then I play again.
On top, I see that you're sharing WebEx. I see an orange. Okay.
I'll give it another try. This time I will only share the PowerPoint.
That works.
Okay. Very good. So thanks for everybody for joining today's session from river flows to flood maps. In this session is very much about how to access data in relation to floods from the Copernicus Emergency Management Service. I will basically go through the presentation, which will contain a lot of links to show you basically where you can download the information and where you can access the information. And then I will provide you also a couple of examples. Now, in the meantime, my colleague Stefania will kindly copy and paste the links that I show in the presentation into the chat. So you can follow up immediately live while I'm speaking to see a little bit yourself if you can access the web pages or links and if you can find your way around. Now, this presentation is not aimed at explaining how EFAS or GLOFAS or any of the other flood mapping products work really. However, don't hesitate, please. I encourage everybody to ask questions in the chat, please. While I'm presenting, I will roughly present 3 elements. But please, I will stop after each element and then give you time and have a look whether we can see some questions. But please don't hesitate. So don't ask questions only about data, but also if you have questions about how products are working in EFAS, in GLOFAS, in the global flood monitoring, or how things are done, also this will try to answer where possible. Okay. Now, having said that, let's see if I can move to the next slide. Yes, okay, very good. Now, so this is what today's little workshop is about. We will look at the 3 elements, basically the 3 key elements where you can flood related data. One are hydrological predictions. So these are outputs from hydrological or models. in EFAS and GLOFAS. So this is basically concerning variables like river discharge, that is, by the way, also used as part of the low flow indicator for the European Drought Observatory. You can get simulated snow water equivalent, you can get soil net wetness index, so also this is obviously an important drought information. You can get the runoff of the model as well, so surface and plus subsurface runoff. So these are, yeah, let's say these are, as I said, is the part on the hydrological predictions. Then we have two parts, and that is on satellite-based flood maps. And I guess these are typically the elements that are most interesting for many of you. One of them is based on the global flood monitoring. So this is basically a fully automatic monitoring system based on Sentinel-1 to provide flood maps regularly for the whole around the whole world. And then there's the second element, which is the on-demand mapping that you've heard also a lot about in the morning. So this is where a user needs, which is typically an authorized, the Civil Protection Authority, needs to activate for a specific area, for a specific region, in order to do a flood mapping for a specific event. Okay. So let's start with the hydrological predictions. And again, I mean, I encourage you really to ask questions in the chat. So bombard us with questions, the more the merrier. Don't be shy. The more questions, the better it is. So hydrological predictions, as I said, I'm not gonna go into detail about how the European and Global Flood Awareness System works, because we simply do not have time, but nevertheless ask if you have specific questions as well. Basically, the idea here with those systems is to provide complementary flood forecasting and monitoring information at European and global scale. And we do that by combining satellite information, then meteorological predictions, in situ measurements that we put into a hydrologic model, and then produce predictions such as the ones that you see on the right-hand side for the European domain as well as for the global domain. There's the two links of the systems here on the bottom of the slide, europeanflood.emergency.copernicus.eu. Same for globalflood.emergency.copernicus.eu. I'm sure many of you know the systems already. I guess this is nothing new for you. For those that do not know the system, please have a look at the web pages. There is an enormous amount of information and documentation around those systems, how they work, what products they offer. So please feel free to browse and have a look also, I guess, after this meeting and in the coming days. Now, what are the two main ways to access information, the hydrological predictions that you get out of the European and Global Flood Awareness System? Well, clearly the map viewers are the easiest way to do so. So on the top right, you see that there's both on the EFAS webpage and on the GLOFAS webpage, you can see the links to the map viewers. For the European one, the real-time forecasts are restricted, whereas for the global one, you will have to register in order to get access, but anybody can register. Now, why do we, I think I need to explain why do we restrict real-time forecasts of the European Flood Awareness System. As I mentioned this morning, early warning is in principle a task of member states or of the countries, and because we are also sending out flood notifications based on the predictions of EFAS, not on GLOFAS, we on request of member states, we have restricted access of real-time forecasts. Nevertheless, all the real-time forecasts after 30 days are made available for free. Also the initial conditions, so the conditions basically of today are freely available. Those are based on the observations that we receive. So there's quite a large information still available. And if you really need real-time information from EFAS, real-time forecasts, I mean, if you're an authority in any case and you don't have yet access, you can request access. If you're a research project, also in these cases, there's a possibility to get real-time access if really needed. And for all others, all the archive and all the hindcast data, reanalysis, medium-range forecast, these predictions, these are all freely available. Now, if you really want to dig into the raw data, then you can go to the early warning data store. This is new. It's for those that know the climate data store of the Copernicus Climate Change Service. Then you will probably know that some of the data sets for EFAS and GLOFAS were available on the climate data store. They are now available in the new early warning data store. It's basically a copy of the climate data store for the early warning information. We have data extraction tutorials there. We have different products, as I said, reanalysis, medium range forecast, seasonal predictions, etc. But also the auxiliary data, upstream area thresholds that we use in EFAS, or the other auxiliary information to really download the information and work with the raw output. Now, I do have to say, obviously, this is more than just visualizing some model output. So you need to have some specific programming or certain technical capacities to process and visualize this type of information. So there is we have really an extensive wiki and user guide. When you are on the EFAS page on the top, on the right-hand side, you see a link to the wiki, EFAS wiki, same for the global, for GLOFAS. You click there and you get to a Confluence page, and where we have a CEMS flood data user guide. And there's really a lot of information displayed there. This is impossible to tell you everything, so I recommend you take you in calm, have a look at the information and read through it and see whether there's some information that is interesting and relevant for you. Let me now one more thing, and then I'll stop for the hydrological prediction, and I will start looking at some of your questions and see if I can answer them. For those that really want to go super deep, meaning that you maybe are interested in running your own hydrological model for your area of interest for your river basin, the hydrological model that we use in those systems is a completely open source model. It's called ListFlood. Here's the link to the GitHub repository. There's a plethora of model documentation, but also utilities and use cases to really get started. Most importantly, also the relevant inputs, so the necessary soil properties, land use, etc. for both EFAS and GLOFAS setups are both available. For the global setup, we use the famous ERA5 reanalysis data set. So if you want to run the GLOFAS setup for yourself, please, then I refer you to the ERA5 dataset in the climate data store. The meteorological forcing you can get also on the JRC data catalog under the link that is given here. So this is, I would say, let's put it this way, this is for the real, the ones that want to really dig very deep into the hydrological predictions and maybe do also some research. For those, everything, all this information is there to really look at the very deep into how we do hydrological predictions. Let me now, I will quickly stop sharing so that I can have a look at the chat. Give me some time to start reading. See, so we have the links. Okay, we have one question on how do you deal with it when there's no in situ data. So yes, very, very good question. If in situ data is absolutely fundamental if we want to know the initial conditions of our hydrological predictions. So we collect quite a lot of them in near real time as well. And it does happen sometimes out of technological reasons that things are not working. In those cases, we use forecast information from the previous day, the precipitation, the temperature, as a proxy to the missing initial conditions, so that we can at least do a forecast even though we don't have in situ data collected. Typically, when there is a technical issue and we will be able to reestablish the in situ data collection very fast. So we never had it really where there's various days without in situ data collection. But if needed, as I said, we use forecasts from the filler. What was the basis for member states to request limiting real-time access to forecasts? Very good question as well. As I said in the morning, it's a responsibility of member states to provide public warnings. And our task is to support member states' authorities with this type of information to help them to provide those public warnings, which is why in this case we had decided to restrict, or it was the member states had requested to restrict this type of information to just provide this type of information to them. They will then combine it with their national, because often there's a long tradition of early warning systems in many parts of Europe, and they will combine it with their own national information, with the local data sets, and use this also to provide improved then public early warnings. For how to access real-time data if you're an authority, what I would recommend you doing is to look at the EFAS webpage and go to the section Collaborate. There is a description of the process how to become an EFAS partner. Under what conditions, very good questions, do you send an early warning for floods? It depends on, so what we typically use return periods to kind of inform of the high likelihood of an event that may be severe. EFAS, one of the elements where we say that is, as I said, is complementary. It means that we also try and look, obviously not at the very detailed, very small floods, but we try and focus on relatively severe floods. So our threshold level that we use for sending out warning is the 5-year return period. We have the information in the web viewer. If you go there, you will see also, of course, the simulations, the hydrograph for all return period ranges, but typically we use the 5-year return period. Again, also here under the wiki and on the main page of EFAS, there is an explanation exactly what are the thresholds and how are those notifications sent. Let me now, I try to get one more question and then we have to move on to the next part. Let me see, I'm scrolling down the chat here. Do you have an example of support to institution outside EU for early warning on floods? So yes, the global system, GLOFAS, for example, is used very much by the International Red Cross and Red Crescent to do what they used to call forecast-based financing. You know, in many regions around the world, there is no or limited early warning information available. And the Red Cross, together also with other international aid agencies, searches or uses GLOFAS amongst many other types of information to predisposition early funding in the case of an upcoming floods for some countries. So this is a very practical use case of how how we support with these systems also outside Europe flood risk preparedness or flood preparedness. Now let me now try and share again to continue. See, so now we go to the now we go to the element of satellite-based flood monitoring products. There's one more slide here on the hydrological predictions. These are examples of what you can do when you access, for example, the raw output data. On the left hand, you see an anomaly map for average river flow across Europe in summer 2024. You can see low flows, high flows. And on the right-hand side, for example, you can plot the mean daily river flows based on the long-term run of the EFA setup from 1992 to 2022. So these are just examples that may inspire you when using the data to visualize how to visualize things. Let's move to the satellite-based flood maps. And there's two elements here. One is the global flood monitoring product. And in a nutshell, this provides a fully continuous global and systematic monitoring of floods using Sentinel-1 for the entire world. And one of the advantages in comparison to what you will see afterwards with the on-demand mapping is it significantly enhances the timeliness of the flood mapping being provided. So we are able in on average less than 8 hours from the sensing of Sentinel-1 to the availability of product to have this information available. Now, the downside of this, of course, is that this is a fully automatic chain, so there's no human interaction. That's why we can be so fast. But the downside is, of course, that this is only designed for Sentinel-1. The advantage of on-demand mapping is that there you have access also to other satellite images. If possible, you can use Sentinel-2 if there's no cloud cover, but also other synthetic aperture radar missions like TerraSAR or Cosmos SkyMed that will also be able to provide you information that in the global flood monitoring currently you will not see. Now we are, as I said this morning, eagerly waiting for the launch of Sentinel-1C because currently only one Sentinel-1 is active, Sentinel-1A. This is really, it unfortunately makes revisit time and frequency less frequent than what with 2 satellites. But again, we hope that with the launch of Sentinel-1C, this situation will soon be solved. Now, what's the best way to access those global flood monitoring maps? Best way is to go through the GLOFAS or EFAS interface. I will show you examples for the GLOFAS map viewer. So once you are there, there's a little tab on top called monitoring, and then you see all the different products there. So you see, we don't only map the flood extent, but we also provide information about, we believe, important information about quality of products, because even though these are based on satellite observations, of course, there's also some uncertainty in those observations. There is also areas where the satellite cannot see. Synthetic aperture radar satellites typically cannot see in very dense urban areas or under vegetation cover. So there are limitations as well on that side, and we believe that it is important for users to communicate this information. So then you can define and manage areas of interest. So you can, and that you see on this little yellow arrow, you can draw an AOI and then basically get information from the GFM, from the Global Flood Monitoring for a specific area and for a specific time period. And this is done through, so you download then vector or raster data, you will be led to the GFM application. In that application, you have then full control over what you want to see. So you can define a time from to, so for example, I want to have all the Sentinel-1 flood extent maps from that have been for this area in 1 month. You can have the information in vector or raster data. You can ask whether to receive a notification, whether there's a new Sentinel-1 overpass and a new product for your area of interest. And something we have indicated developed newly is you can also develop a request for a maximum flood extent, meaning when you have an area of interest like the one that is shown here, and you ask for a specific time period, let's say 2 weeks, and there have been various Sentinel-1 overpasses, when you request the maximum flood extent, it will automatically stitch all the Sentinel-1 images together, and you will get basically all the pixels that have been observed as flooded by all the Sentinel-1 images in the given time period that you have indicated. There is also an API. I will not go into the detail here, so to access the global flood monitoring programmatically. What I want to show you really very quickly here is there's also a wiki which provides the scientific information on how global flood monitoring works, the different algorithms, etc., the quality. But most importantly, for those that really want to start quickly with this type of information, I really recommend you to do the quick start guide. It's really nicely done. It's super easy and takes you by the hand to kind of access the data and start downloading and then using. For the experts among you, we are working on a spatial temporal asset catalog for the GFM data. This will enable you the access to the entire archive of the global flood monitoring, basically since January 2015 until recent, so all the time when Sentinel-1 basically was delivering data. This is soon to come. We hope within the next few months we'll be able to share this access, and then so watch out on news items on this. These are examples of global flood monitoring maps of types of visualizations. You can make a nice animation, or you can just overlay it with background information. These are some recent examples. Just before I stop and answer your questions, let me show you quickly also the second part on the satellite-based flood maps, and this is from the on-demand mapping. There's two elements: the rapid mapping that has been discussed already this morning, so maps that are fast produced for areas of interest, but there's also the risk and recovery. So if you want to do a post-event analysis, sometimes some users require that, then typically users ask for a risk and recovery activation, and then this can then have information like maximum flood extent as well, and various other types of products. There is an on-demand mapping activation viewer. This here is the link. You can search then for a specific mapping activation. Here I took the recent one for Austria, the Central European floods. It's pretty intuitive. There is a menu bar on top where you have production status, details of and then you can download PDF maps. You can download also all the vector data of the flood extent for the areas of interest. And there is even a situational reporting. And something that I would like to highlight as well, which is a nice little hidden feature, is that on the top, on the right-hand side, I mean, besides the API access to the also here, there is also the way to overlay with the latest global flood monitoring information, because sometimes, as I said, sometimes the on-demand mapping activations will take, of course, also Sentinel-1. This is kind of our backbone information, but they will use other information as well, TerraSARIX, etc. So it's nice to have these two products in one viewer and be able to overlay them. Let me just quickly, I think there's only one slide left, and then I will stop and answer your questions. So here's some example of visualization of satellite-based flood maps for recent events. These are floods in Emilia-Romagna or the ones in Central Europe. So again, all this data, you can download the maps, which is a full PDF with information. Basically, it's ready to be printed out. As well as the actual vector files of the flood delineations to really work them in a GIS environment and kind of do spatial analysis. So let me now stop, and then I will answer your question. So let me see, I will go through the chat. Where did we stop? Let me see. Yeah, this is not really related to the flood maps, but thank you for the question on the European protection standard data set. This is indeed something that I also fully agree is something that would help a lot, in particular developing, of course, European but also global scale information. Because this type of the information on protection standards is fundamental for our forecast, but is as well also fundamental if we want to for the flood monitoring, I believe. So definitely I can just agree on that, and I don't have a solution. We don't have what we do is inverse modeling often to derive, estimate flood protection for specific areas. But yes, an spatially explicit database on flood protection standard would also be highly appreciated from our side. I know there's the FlowPros data set, which is a collection, I think, started by the colleagues in the University of Amsterdam. But still, there's definitely more work to do on that side as well. Can we request risk and recovery mapping for research purposes? The short answer is no, because in the end, I mean, requesting an activation of risk and recovery, but also rapid mapping, in the end, costs money. So the main aim here is to respond to real emergencies and to support civil authorities. Now, if you team up with a civil authority that may so you can channel your request through them for a post-event analysis, then yes, then you will be able to request also a risk and recovery mapping product post-event analysis that you can then maybe use in your research analysis. Very good. What is the spatial resolution of the flood extent data? Very good question. So the global flood monitoring, well, first, Sentinel-1 provides information at maximum resolution of 10 meters. In the global flood monitoring, we have decided to increase that slightly to 20 meters, because we know there is some noise in the SAR information, and by averaging up, increasing the spatial resolution slightly, you'll be able to better filter out the noise that you get in the SAR products. For the on-demand mapping products, this is varying, obviously, depending on the sensor you use. So either Cosmos SkyMed or TerraSAR X or Sentinel-1, the spatial resolution or other Copernicus contributing missions, the sensors are different. So here the spatial resolution can vary. Typically, let's say the Sentinel-1 is, or Sentinel-2, so 10, 20 meters is our bottom line, and then we go mostly higher resolution. So we often, when we use any data from the Copernicus contributing missions, those are typically even higher than just 10 or 20 meters, but maybe a few meters in the few meter scale. Regarding the satellite-based flood, which can you download as PDF or shapefile? Yeah, I mean, so the satellite-based flood maps, the on-demand mapping products, you can download as PDF and as vector data. However, as the name of the component already said, on-demand mapping, meaning this has been requested by an authorized user, which is typically a civil protection authority, and it's only for specific areas of interest. If you go to the on-demand mapping activation viewer, you will see always the areas of interest. If you need a full picture of an entire river basin, then you need to go and have a look at the global flood monitoring product. There you will be able to get a coverage of an entire river basin. However, as I said, this is then based only on Sentinel-1, and there's then limitations on revisit frequency in particular, because we currently only have one Sentinel-1A up and running, as Sentinel-1B unfortunately has had an incident and therefore is not producing images anymore. Let me see, we are almost at the end of today's session.
Yes, Peter, there is a question from Utah. I just copied it again in the chat.
Yes. Okay. Yes. Very good. Thanks, Utah, for this question. As I said this morning, I mean, we do plan for both systems. We are working also in the next major releases already to start integrating AI, in particular when it comes to parameter learning and regionalization of model parameters. We believe that basically merging AI approaches with the classical physics-based modeling is the way to go. So this will continue in the future as well. Major releases will come, and we will probably progressively integrate more and more AI into our systems, both for EFAS and GLOFAS. But I think we can already say now, even though let's say we are just at the beginning of this journey, I would call it. We are, I think it opens up a lot of new avenues and a lot of new possibilities. So there's really a lot of exciting developments ahead of us, and you will see, I think, a lot of progress being made also from colleagues at ECMWF, of course, when it comes to meteorological forecasting in the whole world of hydrological and meteorological modeling and forecasting. I think we have 2 minutes left. There is one, are you using commercial data and high resolution as well? So yes, we do use higher resolution data for the on-demand mapping component if they are part of the Copernicus contributing mission. I do believe, I'm not sure, 100% sure if Capella data is part of the contributing mission. I know that the colleagues from ICEYE, who have also their own SAR satellite constellation, is part of the Copernicus contributing missions, and as well as others as well, Worldview, etc. So a lot of optical sensors as well. So yes, we are including commercial data, but only for the on-demand mapping activation and only if they're part of the Copernicus contributing missions. And I think I'm looking a little bit at the time. I think we're about to probably be not kicked out, yes, because we're in the main room. So I think I will stop here. I thank everybody for participating. It was great having so many questions. This makes things much more easier than just presenting. So really happy that you participated, and I hope you found it interesting. If you want to find out more about this type of information, don't hesitate to contact us. I think, if I may ask Stefania to add maybe a couple, there is info@efas.eu, but there's also contact forms on both EFAS and GLOFAS web pages that will also help you for that global flood monitoring, as well as if you have questions on the on-demand mapping, then we're of course happy to move them or share them with our colleagues working on the technical details of this component. So thanks very much for your participation, and I will stop here for a moment and wait for further instructions here from the colleagues on the next session.
So on this main room, we will now have the wildfire splinter session. Once all the colleagues have joined from the other splinters, they will close in 25 seconds anyway. So we will all find ourselves back in this room. I think all 177 participants are back in the main room. Thank you to all the moderators for sticking to the timetable. We will now move to the second round, which for 45 minutes will have the main stage. I don't think this is correct. I think this time devoted to wildfires, unless oh yeah, it's forest fires, but the color is strange. Okay, forest fires. I thought it was floods again. Sorry. So forest fires, the colleagues interested by floods, drought, mapping, and human settlements and building footprints, you're invited to move to the other rooms, which I guess are open or will be opened in a second. Yes, they are now open. See you at 4:15 sharp for the conclusions. So we are in the splinter normally on wildfires, but I see Thomas in this room. Well,
yes,
I guess he should be in the other one.
WebEx is funny with us. It doesn't let me, but now I moved there. Bye-bye.
Ciao, Thomas. And I will obviously let the colleague chairing this session on wildfires take the floor. I think we need to make Hector. That's it. That's on the way. Hector, a co-host.
Can you hear me?
Yes, Hector. we can, Hector. We cannot
Yes,
see
I can.
you. We
Okay,
cannot see you, yes?
I cannot share my screen.
My colleagues will make sure this is possible, hopefully.
Okay.
Hi, Hector.
Hi.
So you are the presenter now, so you should be able to share your screen.
Okay, now I can see it. Yeah. Okay. Can you see it? Yeah.
Yes, we can see it.
Can see it. Yes, Hector. Okay. Okay, I guess we can start. Okay, let me introduce myself. I'm Hector Alfaro. I'm not an expert in Copernicus. I'm a firefighter. I'm the focal point in the ERCC, the Emergency Response Coordination Center in Brussels. And I will give you an overview of how we use all these tools. And I will be supported by Alfredo and Duarte, just in case we have a more technical question. Okay. First of all, I would like to explain that the ERCC is a coordination center. So when there's an emergency in Europe or another part of the world and countries asking for support, from the ERCC, we coordinate the support that the different states, usually states that are part of the mechanisms, are providing to this emergency. For that, during the summer, from mid-June until mid-September, we reinforce the ERCC with wildfire support team. So daily we have one duty officer from the ERCC, 2 national experts that are coming from different countries, member states, or states that are part of the mechanisms, and 1 scientific expert from the Aristotle Consortium that are meteorologists or another type of expert, and 1 secondary national expert that is me, it's only me. So this year we had 16 in total, 16 national experts, 6 scientific experts, and 6 duty officers providing or supporting when we have activation and during the whole summer. I divide my presentation in 2 parts. The first part will be about situational awareness. As you know, for emergencies, it's very important to have a situational awareness of what's going on, but before we have the emergency and also during. So on this purpose, we use mainly 2 types of tools that are the European Forest Fires Information System, EFIS, and also for emergencies outside Europe, we use GWIS. Now I'm going to share my browser. Let me know if you can see it.
Yes, we can see.
Okay, here we have the EFIS. In EFIS, you have different tools. You can go to through here or through here. The first one that we use is the current situation viewer. I have it open here. In here, what we use is we try to have a big picture of what's going on in Europe daily and in the coming days. For that, we mainly use the fire danger forecast. Yeah, now it's here. So we try to identify with the fire weather index which areas are or have the highest danger. So it supports us when we have to make some decision or to support the countries with this information. Here you can have this weather index from the CEMS for Meteo France. The main difference is the resolution, but we also can access to different indices that we will see later in the presentation, some of them. Okay. The tool also can allow you to move and go forward and back, so we can see how the index is changing in the days. And you have the forecast for, you can see here, is 11 is 10 days forecast. Okay. Then another tool, well, here we have the legend. I guess that this is more or less easy to use, and this tool is very easy. It's very easy to use. It's just you need to start using a mob. You have several layers that you can use. But another tool that we use a lot is the statistics portal, because we need to know how is the seasonal trend, what's happening, and for that we use the statistics that EFIS is providing us. I have to say that it's important to know that in statistics, the info is coming from fires that are larger than 30 hectares. And this is very important because if you check, for instance, the burn area, so the number of fires that we can see in this year, I have, you can choose here the year. For instance, in 24, we can see that this year the number of fires, the cumulative number of fires is much above the media. Okay, but it's important to know that fires above or larger than 30 hectares, because if you go to, depending on the countries, but for instance, in Spain, 70% of the fires, between 70 and 80% of the fires are below 1 hectare. So it's important to take into account the data we are using. This part of the tool, we can have information selecting the year and compare. You can use for Europe in the European Union, European non-European Union countries, all the countries that are part of the mechanisms that are 37, the 27 plus 10 participant states, and you can check the year you would like to have the information. And the information you can use weekly burn areas, also the emissions, number of fires, and the thermal anomalies from beers and MODIs, and the severity rating. Okay. You can have the info for these areas of interest, or also you can select one country if you have to check only the information for one country. Okay, and then after that, I will show you another tool that we use usually, that is the forecast, the long-term forecast. So we can have the anomalies, temperatures, and rain anomalies for the coming weeks and also months for the season. So with all this information, what we go, I'm coming back to the presentation. Can you see now the presentation?
Yes, we can.
Okay. With all this info, daily we prepare a briefing, and during this briefing, we try to identify for each day in which part of Europe we could have activation or we could have problems in the coming days. So just to be ready, and to in case that we have to mobilize assets like aerial means or whatever from one country to another, we need to take into account which parts have the high danger, but not only this day, if not also in the coming days. So for instance, if we have a fire in France, of course, usually you are going to mobilize means that are close to France, the closer mean, but it's better if you move, in this case, aerial means from Italy than from Spain, because you have the same high risks. Okay, then we analyze for each of these points, so this square that we identify, we go deeper in the fire weather index, also in the sub-index that are part of the fire weather index. And of course, with the support of these Aristotle scientifics, we analyze also the forecast and the weather to be able to understand what's going on, not only with the fire weather index. Here we have a description in France of how was the situation, how it was going to evolve in the coming days, and also temperatures and everything. It's the same for Sicily, and another example in the border between Bulgaria and Romania, where we had an activation during this season. Okay. Then, as part of this situational awareness, we prepare every week. We have a meeting with all the states and with the ERCC, and we prepare. We do a eco wildfires bulletin that is delivered between all the mechanisms countries, and in this bulletin we have information about all the emergencies that are ongoing in Europe, and also the fire activity and how is the trend during the year and the fire danger. This information is provided by the ERCC. Okay. This is what we do just to have a situational awareness of how is the situation in Europe. Then we move to monitor active fires. When we have fires, we monitor them, but not only fires which we have some assets deployed. That means that the ERCC has been activated. or the mechanism has been activated, but also another fires in other paths, yeah, to know how is the evolution. So for this purpose, we use also EFIS and GWIS, depending if it's in Europe or outside Europe. Copernicus is activated, we'll see it now. And then we also like to use the Copernicus browser to have a satellite image. So I will come back to my browser. Okay. Can you see? Okay. Can you see my browser?
Yes.
Yeah. Okay. Okay. Then the second part of the EFIS is here. Here we can see when we have active fires, anomalies, and here we can see the burn areas. I will go to the last 30 days, the burn areas. Okay. We have, in this case, we can choose the supervised or not supervised burn area. The main difference is that this one is not supervised, so it's faster. You have this faster than the supervised one, but the supervised one is more accurate. So let's see the last activation of the mechanisms that was in Greece in this fire in Silo Castro. So what we can see here is that when you press in the fire, you can display the information about the fire, the day that started, the last update that is the day that there were no more hotspots, so it didn't make any sense to continue updating it. Some information about the location of the fire, and here we have the total burn area and information about the type of vegetation that have that burn. Another important information that we use is the fire danger chart. Okay, here we have it, and in this case, what we have is for the place where we have the fire, we can display the fire weather index, but also all the sub-index that and the anomaly and the ranking that are part of this index, and so we can see the trend. In this case, the fire started the 29th of September, and we have the values of the FW in 2 days before that and later. So we can see that the trend was for this fire was going to be the same the next day, but after the 1st of October, in the 1st of October, it was going to go to decrease. So and at the end, this was the day that the fire was more or less under control. So it gives us a lot of information about what forecast of what will happen in the coming days. Okay, then now I will do the same, but instead of with EFIS, I would like to show you the same in GWIS, because we can see now we have an activation in Bolivia. In Bolivia, one of the main differences is that in GWIS, we don't have, for the one areas, we don't have the supervised ones. So as you can see here, these fires are now active, so we can check the beers that are the anomaly, and with this, with the beers, we can see which flanks or which part of the fire have more activity. In the legend, you can see the time, how much time passed since those hotspots were detected, EFIS and MODIS. Now, while we are talking, we have a fast team, Forest Fire Advisory and Assessment team from Spain deployed under the mechanisms in Bolivia, supporting them with those fires. And the last week, also there was a fast and 41 firefighters from the brief from Spain also. And as in EFIS, we can see the burn area, and we have the more or less same info. Okay, the start date, the last, you can see that those fires, because it started being a lot of fire, now it's just one, but start in July, mid-July, and it's we are in October, and the last update has been done today, because the fire is still active, and you can see here that it's more than 4 million hectares. So we can have lots and lots of info. But also we can check the fire danger chart, because we know that some rain is forecast, so the fire weather index should be improving in the coming days. So we can see here we are in the 11th of October. We come with very high dire index. You have here the values, and it will be decreasing on the 16th of October. The values will be very, very low, because some rain is expected in all these areas. So let's see if the forecast is accurate or not. Okay. Also, one of the difference with the fire weather index is that in GWIS you have also the lightning forecast, but I cannot say, maybe later if we have time, Duarte or can comment something about that, because I don't know if it's very accurate or not, this lightning forecast. Okay. We come back to this. Okay. I will go back to another tool that we use a lot is to move this. Okay, the Copernicus mapping service that, as you know, Copernicus mapping service can be activated by the countries, but member state or another states when they have an emergency, not only for wildfires. And in this page is the public information of this Copernicus activation. If you go here, you can select wildfire and apply filters, and then we can see how many times it's been activated this year. I guess around 20 only for wildfires. And what the Copernicus can support us is because as you know, when we have the information from EFIS, the information, the data of the burn area is updated 1 or 2 times per day. Depends, no more. But with the mapping activations, we can have sometimes update information more than 1 or 2 times daily. In this case, I would like to show you this one that was the activation in Greece. In this activation, you can see in the viewer how many maps were done. The first one, delineation, the second in the area. When you activate this, we can do it as ERCC when we think that we need info in fire and in an area that has wildfire. But in this case, was activated by Greece. So while the fire is active, Copernicus is updating the information. So in this case, we have several products. In this part, you can see all the products and when they were delivered. Here, you can download all the information, all the maps, and in this part, we have have it open here, it's better. A situational report that is okay. In the situational report, you have a timeline of the activation and how was fire danger, a description of the event, when it started, and so when each of the products were delivered, and also the analysis that the system, the people that are working here are doing, because it's not it's a deep analysis of the area that is affected, which area is exposed, how much people are exposed to the fire, asset, roads, and type of vegetation that is burning. It's a lot, and also you can have this map in Google Earth. Cannot see, I don't know, maybe it's a browser, I show you later. Okay, and the damage assessment. So it's a very interesting report where you have a lot of information. The same for Bolivia. This one is now active. So if we go to the production status, we can see that those are all the areas of interest. In this case, we start with some areas here. Now some of the fires are starting increasing in the north and in the west of the country. And the team that is working there, the fires, is giving, is sending, is requesting new areas of interest, and Copernicus is working on it. So we can see that some of those products are planned for the 15th of October and 9th of October. Okay, and the rest is the same. Okay, another tool that we use is the Copernicus browser. I would like to show you in this case the browser of the this fire in Corinthia. So you can see for the 29, we can see here, if we go here, we can have an overview of the situation. So we can see the burn area, but also we can compare with areas. If you add here to compare, okay, we can compare with in the same area in another date before the fire started. 16, so we go to then okay, let's go. In this case, the fire was okay. Well, it doesn't matter. Not what we need. Okay, don't worry. So what I was trying to show you is we'll go back to we can see in another places. Yeah, you can compare between days how is the fire is moving or is spreading. Go back to the presentation.
Sorry, Hector, this is
Yeah.
Adelaide. Since 15 minutes left, maybe you can check with Alfredo and Duarte if there is any questions. By the way, but can you activate your camera because we are not able to see you?
Oh.
And if there are no, I saw that Duarte already.
It was...
okay, now it's on. Duarte already addressed some questions. Let's see if anyone else has questions. Then you can go back to the presentation. Sorry.
No problem. Yeah.
Okay, thank you, Adelaide. So yeah, Hector, we have a question from Joanna. So what is the time frame of responsiveness and share of assets, namely airplanes, by the moment of request by the state in need?
Well, this depends because the mechanism is based in the offer that the different states that are part of the mechanisms offer. It means that when one country is requesting, we put in an internal system that we use for communication that is called CESIS. And we give 1 hour to the state so they can do spontaneous offers. If we have not a spontaneous offer, we start mobilizing assets with the pool or rescue. It means that it can last depending of the country that is requesting, and if there as it's close, it can be 24 hours. So it's not a fair response. The mechanism is we can see that it's the third layer of response. I don't know if
Yes. Okay, Hector. We don't have for now any more questions. You can continue your presentation, please.
Okay. Okay. So with all this information and using those tools, what we prepare in this daily briefing, we try to see also which parts in Europe are active, have more hotspot or more active. And in this case, as is happening during the whole summer, we have Ukraine that with a lot of hotspots for obvious reason, but we also have seen that in the Balkans during this summer, most part of the summer, there was a lot of activity and unlikely, not normal. In this case, for North Macedonia, where we had this year during this year 2 activations, we go deeper in the place where is the activation. So we check the fire weather index. We try to see how is the fire weather index, how is it going to evolve using the forecast that FIS is providing us. But we also like to know how the sub-index that are part of the fire weather index are, which values have. So here we had this activation was the 15th of July, but we knew that the 20th of July there was a big opportunity to stop the fire, so they will not spread so fast. Another example is in North Macedonia, in this case the Negotino fires. So we were using, as you can see, all this information comes from the tools that we were seeing before. And we have the surface that was the van that was the van area in this small one, and the van area at this time, the 16th of July in this fire, because this fire, for instance, started the 10th of July, but the activation of the mechanism was the 15th, as I said before. It's not the mechanism is not a fair response. So when one country is overwhelmed about the situation is when they activate the mechanisms. Okay, then with all this info, what we were seeing is how the fire was moving. And we were seeing in the forecast that there was going to be some change in the wind, and that the wind was going to be northeastern winds. So we were not very worried because the fire was going to start spreading to these areas where the firefighters should have an opportunity. And also in the next days, the anomaly in this case was going to be low. The same for this fire in Bulgaria, in the border with Greece, analyzing the hotspots, trying to see which part were more active. What we were seeing here is that during the night, the growth of the spread of the fires was decreasing, and some flanks, were stopping in croplands, and because it couldn't spread more. So in this case, in Bulgaria, we have the same info, but with this map from Copernicus rapid mapping, where we had which part of the fires were more active at this point, and here we have some hotspots. In this case, what we were seeing is that with using this NDVI index, that the greenest forests were limiting the spreading because of the high humidity of the light fuel. Okay. And this is another example in Turkey where we had the fire that lasts a couple of hours. So you can see in the image that burned around, I guess it was like close to 1,000 hectares in some hours. So it was very explosive fire, and so it burned everything. In this case, is another example in Albania. This comes from the rapid mapping, and this is from the EFIS. We had several activation in this area. In this case, the response of the mechanisms was faster because this fire is close to Crete in Greece, and two planes from Greece were offered as a spontaneous offer from Greece, and they just went there in 3 or 4 hours, no more. I mean, it's like 20 half an hour flying time. So it was this was a very fast response. In this case, we see in yellow the first fire, the area that was burned in the first fire. Then there was a recognition, and in orange you can see what burned later. So for us, when you see this and when you see this part, it wasn't very, I would like to say it wasn't very difficult fire, because we saw that most of the activity was in this part, and this part was between two van areas, so it didn't have too much space to spread. So we also use the statistics from EFIS to see what was happening during this summer in the Balkans, for instance, and we can see here that the pan area was over the maximum of the last 17 years. In this case, in North Macedonia, Bulgaria, Turkey. So it's one of the reasons we could see that in these eastern regions, they were breaking records in terms of fire activity. And they have several long heat waves during this summer that joined with windy episodes and fuel available. It penalized in having these fires and this situation. And the opposite in the Western country, we had less activity than usual. And this is the type of map that the Copernicus mapping service is providing, where you have the delineation of a very accurate delineation of the fire. In this case, it's wildfire in Madeira, in Portugal, and you have all the numbers of the type of vegetation, facilities that affected, so on. Okay, and if you want to have more info regarding this wildfire season in 2024, the analytical team that works in the ERCC, and we work close with them, has prepared this story map that is very nice, and it can give you an overview of how has been the 2024 fire season. You can see here, and it's public. So here you have information about the capacity of the mechanisms and how it works, and monitoring, and also EFIS, with what type of tool we use, and some statistics in the response in 2024, and also all the maps that the analytical team has been providing us during the season. I don't know if we have more info. We
still have more 5 minutes. And for now, let me see. There is a question. Can we have the link to the 2024 wildfire season in maps?
Yeah. I think in the I saw copy it. Yeah, I think I can copy and paste in the, but it will be in the presentation. Anyway, I'm going to try to copy if I can. I'm trying to. Okay, I'm going to stop sharing. So, and I will try to copy in the chat.
Okay, meanwhile, Hector, I don't know, you still have 3 minutes. I don't know if you want to wrap up everything or to conclude your presentation.
No, I just would like to say that for me, I think that it's clear and it's very important that knowledge and science are really, really important for fighting wildfires. We can see that each year we have more and more extreme events, and we need to learn how to and to be ready to fight them. So in the future to avoid this type of big fire, but it's another thing. And I guess that all these tools that the CEMS is providing us are really useful for the people that is working in the front lane. And we don't understand fighting wildfires without this tool, because in the past we were working in a reactive way, always going after the fire, and now we can be proactive and we know what's coming, what can happen, so we can be ready and work in another way. And
okay,
it's time. I don't know.
Well, the countdown will start in a few seconds.
Okay, and I think now I copy the link, so you have the link in the chat now.
Yeah, got it.
I think that there's a question, but it's more for you, Duarte.
Okay, I will reply in the chat. Okay, thank you, Hector. Thank you.
Well, muchísimas gracias. It was very interesting to hear a user perspective on and the combination of how these tools, products, and information is turned into assets for both preparation and response. So really, thank you so much for this presentation. So we'll see you all soon in the main room. Well, we are in the main room, so we'll wait for our colleagues to come in, and for the wrap up of this very intense, very packed, but very interesting day. So it looks we're all back together in the main room. So it's time to call this meeting to a close, and I will leave the floor to Tom de Grove, who's the head of unit responsible for both the scientific work and the operational delivery of products and information and data sets. I'll leave Tom conclude this, again, very intense, very inspiring, very interesting, and very informative day. Tom, the floor is yours.
Thank you, Stefan. And indeed, we come to a close of a very busy day now. I think we're all overwhelmed with the information we have received. And but that was the purpose, to give in one day as much as possible an overview of the status of Copernicus and where we are going. If you have more questions that you have put in the chat, they will be answered, of course, later after the conference. The presentations will be available, and the YouTube, the recording will also be available afterwards for others to watch. We had 3 objectives with this day. One is to give visibility. Sometimes we hear not everybody knows about Copernicus, so the idea here is to reach out wide and broad to users that we know, but also perhaps other stakeholders that we don't yet know or that are not aware of Copernicus, to show what's there from the very shallow view all the way to a deep dive in the afternoon. I think you've heard about the political context, the details of the products, hand-on training, and all kinds of things. Second was to show the role of science. Without science, nothing can happen. It wouldn't be such a good system. It is very complex and technical. CEMS is at the forefront, and we want to keep it there. It's built on science. It's implemented in the science body of the European Commission, and it needs all of this to also drive more science. So we saw where we are, what the opportunities are, but also the feedback that is then received by this interchange with users and scientists helps to be very focused on the future of Earth observation, better modeling, understanding the complexity. And thirdly, it is about giving visibility to the many partners in the Copernicus system. It is not done by one person, one group. It is many organizations working together, scientific, policy, operational, public, private, but also users. The feedback loop is very important to keep the service being very focused on what it needs to do. So I think we achieved these 3 objectives. We had many people online from over 60 countries, I think. So I'm sure some people did not know Copernicus before, and I hope they do now. Others are aware of the new elements in Copernicus and were able to ask detailed questions in deep dive sessions. And of course, it is a continuous dialogue that we really want to continue every year, but also during the year, of course, in the meetings of the individual components, but also bilaterally with you. Next year, I hope we meet in person. We have a plan of doing an in-person meeting, hybrid, of course, to allow for more people to connect. But the virtual format, while very useful and effective, has limitations of not being able to talk and do all the networking that you can do in an in-person event. So perhaps next year we will try to move to that again. With this, I can conclude, but not before thanking everybody that has made this event possible and that makes the Copernicus service possible. Definitely the 5 team leaders in my team that have organized many of the sessions on the various components, Peter Salomon, Andrea Toretti, Thomas Kemper, Simone Dalmasso, but also Jean-François Pequel, who is just leaving as team leader and is being replaced by Simone, and Jesus San Miguel. They drive this in my organization, the development, very dedicated, and make sure that all these components are being developed further and further. all the experts in their teams, many of those you have heard also online, but also the colleagues of DG ECHO and DEFIS with whom we work on a daily basis to make sure it meets the requirements and it looks at whatever is happening in the space domain. Also, the main contract, all the contractors that are funded somehow through this program, thanks a lot for all their dedication. Some of them work on a 24/7 basis and it's difficult. Thank you for that and for trying to make this service always the best possible. And again, the users for your feedback, give your feedback positive or negative, because then we can indeed make it better. But also, please promote further the service. If you have learned something today, you can bring this message to your colleagues in your countries, in other organizations, because it's important that people know what is available. And also that citizens know what is available. So if you do external or public communication, that is always nice to see. Finally, thanks a lot to those that made this day possible. The MC, Stefan, thanks a lot for organizing the sessions and sticking it all together. But also the back office, Adelaide, Andre, and Fabio have done an excellent job in spite of the difficulties that are always there with technical systems like this, but everything went very smoothly and we managed to have an excellent call. So thanks a lot and a big applause to everybody that joined, and see you next year.